Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, ratios and rates. Here are the objectives that we look forward to achieving at the end of this topic. At the end of this topic, you should be able to express a ratio in its simplest form. You should be able to divide a quantity in a given ratio. You should be able to solve practical problems involving proportional sharing. And lastly, you should be able to solve practical problems involving rates. We will begin with the first part of our topic, which is ratios. A ratio compares things. So a ratio compares one quantity to another. Let's consider this example. Kofi has 2 pens and 4 pencils in his bag. We can use a ratio to compare the number of pens to the number of pencils in Kofi's bag. The ratio of pens to pencils in Kofi's bag is written as pens is to pencils. So that is how this is read. Pens is to pencils. And this ratio, that is the ratio of pens to pencils, is equal to the number of pens, which is 2, then you bring your colon, then the number of pencils, which is 4. So the ratio of pens to pencils in Kofi's bag is equal to the number of pens, which is 2, you bring the colon, then the number of pencils, which is 4. Let's consider another example. There are 6 goats and 4 cows on a farm. We can compare the number of goats to the number of cows on the farm. The ratio of goats to cows is written as goats is to cows. And this ratio, that is the ratio of goats to cows, is equal to the number of goats, which is 6, is to the number of cows, which is 4. We can see from these two examples that we have used a ratio to compare one quantity to another. In the first example, we compared the number of pens to the number of pencils. In the second example, we compared the number of goats to the number of cows. Let's learn more about ratios. The order in which a ratio is given is very important. Now, this is what I mean. The ratio of A to B is written as A is to B, and the ratio of B to A is written as B is to A. So in a ratio, the first quantity comes first, the second quantity comes second. If there is a third quantity, it comes third. The ratio of A to B is written as A is to B, and the ratio of B to A is written as B is to A. So we can see that the ratio of A to B is different from the ratio of B to A. Let's go back to our example that we considered in the previous slide. In the first example, we said that Kofi had 2 pens and 4 pencils in his bag. So the ratio of pens to pencils, that is pens is to pencils, is equal to the number of pens, which is 2, is to the number of pencils, which is 4. So the ratio of pens to pencils is 2 is to 4. But the ratio of pencils to pens is equal to 4 is to 2. So the ratio of pencils to pens will give us the number of pencils, which is 4, and the number of pens, which is 2. We can see clearly that the ratio of pens to pencils is different from the ratio of pencils to pens. So in a ratio, the order in which the quantities are given is very important. Let's apply this same thing to the second example that we considered. There are 6 goats and 4 cows on a farm. The ratio of goats to cows is equal to 6 is to 4 because the number of goats are 6, the number of cows are 4. But the ratio of cows to goats is 4:6. So the first quantity comes first, the second quantity comes second. If there's a third and other quantities, it will be written in that same order. Let's learn more about ratios. A ratio can also be written as a common fraction. The ratio of A to B can be written as A divided by B. The ratio of A to B can be written as A divided by B. Let's go back to our example again. We have 4 pens and 4 pencils in Kofi's bag. The ratio of pens to pencils is written as 2:4. We have seen that a ratio can be written as a common fraction. If we have A:B, it can be written as A divided by B. So if we have 2:4, it can be written as 2 divided by 4. So the ratio of pens to pencils can be written as 2 divided by 4. We can see that 2 divided by 4 is a fraction that can be simplified further. 2 will cancel itself 1 and cancel 4 2. So you have 1 divided by 2. Now we have seen from here that A:B can be written as A divided by B. In the same way, A divided by B can also be written as A:B. So if A:B is the same as A divided by B, then A divided by B can be written as A:B. So it means that 1 divided by 2 can be written as 1:2. So the ratio of pens to pencils can also be written as 1:2. Now we can see from this example that a ratio can be broken down into its simplest form. Here we had the ratio of pens to pencils as 2:4, but as we can see clearly, 2 will divide itself 1 and divide 4 2. So we can break this ratio down into 1:2. Let's apply the same thing to our second example. We have 6 goats and 4 cows on the farm. The ratio of goats to cows is written as 6:4. As we have seen from here, A:B can be written as A divided by B. So 6:4 can also be written as 6 divided by 4. Now when we write 6 divided by 4, we can see that we have a fraction that can be simplified further. We will have 3 divided by 2. As we have seen here, A divided by B can also be written as A:B. So 3 divided by 2 can be written as 3:2. It means that the ratio of goats to cows can be simplified as 3:2. Let's learn another thing about ratios. In order to express two quantities as a ratio, they must have the same unit of measurement. We have seen from the previous slide that a ratio can be expressed as a fraction. When we express those two quantities as a fraction, we cancel out the common factors. Now, because we are cancelling out the common factors, we have to make sure that those two quantities that we are comparing must have the same unit before we can cancel out. Now, this is what I mean. Let's say that we have pipe A and pipe B. The length of pipe A is 5 centimeters and the length of pipe B is 125 millimeters. We want to compare the length of pipe A to the length of pipe B. We can use a ratio. The ratio of the length of pipe A to the length of pipe B will be equal to the length of pipe A, which is 5 centimeters, is to the length of pipe B, which is 125 millimeters. Now, before we can express these two as a fraction and simplify further, we have to make sure that both of them have the same unit. So we have two options here. It's either we convert 5 centimeters to millimeters or we convert 125 millimeters to centimeters. To convert one unit to the other, you need the rate of conversion. We learned these rate of conversions in JHS. In JHS, we learned that 1 centimeter is equal to 10 millimeters. We are going to use this rate to convert one of these units to the other. We know that 1 centimeter is 10 millimeters. So if 1 centimeter is 10 millimeters, then 5 centimeters will be 5 times 10 millimeters, because 1 centimeter will give us 10 millimeters. So 5 centimeters will give us 5 times 10 millimeters, or 10 millimeters times 5. And that will give us 50 millimeters. So 5 centimeters is the same as 50 millimeters. Now we can replace this 5 centimeters here with the 50 millimeters. So the ratio of the length of pipe A to the length of pipe B is now, instead of 5 centimeters, we have 50 millimeters is to 125 millimeters. Now these two quantities have the same units, so we can express it in the form of a fraction, then we cancel out the common factors to get our ratio in its simplest form. 50 millimeters is to 125 millimeters can be written as 50 millimeters divided by 125 millimeters. So millimeters will cancel millimeters, then we will have 50 divided by 125. 50 divided by 125 will give us 2 divided by 5, which can be expressed in the form of a ratio as 2:5. So the ratio of the length of pipe A to the length of pipe B is equal to 2:5. We can also see from here that because the quantities we are comparing in a ratio have the same unit, a ratio does not have a unit. So here the unit will cancel out, so our final answer will not have a unit. We have learned a lot in this video. We have learned that ratios compare things. We have also learned that the order in which a ratio is given is very important. We have learned that a ratio can be written as a common fraction. And finally, we have learned that in order to express quantities as a ratio, they must have the same unit of measurement. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply all that we have learned in this video to solve some questions. Bye-bye. Welcome back. We are on the topic ratio. We started learning about ratios in the previous video. We learned that ratios compare things. We also learned that a ratio can be expressed in the form of a fraction. But in order to do that, the two quantities must have the same unit of measurement. In this video, we are going to apply what we studied in the previous video to solve some questions. The questions for this video are: express each of the following ratios in its simplest form. 18 hours to 2 days. B. 25 centimeters to 3 meters. And C. 3 kilograms to 800 grams. Let's begin with the first one. 18 hours to 2 days. We learned in the previous video that before we can express two quantities as a ratio in its simplest form, we have to make sure that the two quantities have the same unit of measurement. Here, the first one is 18 hours and the second one is 2 days. So you have to make sure that they are both hours, or days. Okay, so in order to do that, we need the rate of conversion. We learned this rate of conversion in GHS. We learned that 1 day is equal to 24 hours. Now, using this rate of conversion, we can convert 2 days to hours. 1 day is 24 hours. So it means that 2 days will be 2 times 24 hours, and that will give us 48 hours. Now, we have 2 days in terms of hours. So our ratio, which is 18 hours is to 2 days, is now 18 hours is to 48 hours because 2 days is 48 hours. Both of them have the same units, so we can express it in terms of a fraction. This will give us 18 hours divided by 48 hours. Hours and hours will cancel, so you have 18 divided by 48. 18 divided by 48 will give us 3 divided by 8. 3 divided by 8 can be expressed in a ratio as 3:8. So it means that the ratio of 18 hours to 2 days is 3:8. The next question is 25 centimeters to 3 meters. We have to make sure that both of them have the same units. So we will need the rate of conversion. The rate of conversion between meters and centimeters is 1 meter is equal to 100 centimeters. We can use this rate of conversion to convert 3 meters to centimeters. We know that 1 meter is 100 centimeters. So 3 meters will be equal to 3 times 100 centimeters. And that will give us 300 centimeters. So our ratio, which is 25 centimeters is to 3 meters, is now 25 centimeters is to 300 centimeters. We can express this in terms of a fraction as 25 centimeters divided by 300 centimeters. Centimeters and centimeters will cancel out, so we will have 25 divided by 300. 25 divided by 300 will give us 1 divided by 12. 1 divided by 12 can be expressed in a ratio as 1:12. So the ratio of 25 centimeters to 3 meters is 1:12. The last one is 3 kilograms to 800 grams. We have to make sure that they both have the same unit. So we need the rate of conversion between kilograms and grams. In JHS, we learned that 1 kilogram is equal to 1000 grams. We can use this rate of conversion to convert 3 kilograms to grams. We know that 1 kilogram is equal to 1000 grams. So 3 kilograms will give us 3 times 1000 grams. And that will give us 3000 grams. So our ratio, which is 3 kilograms is to 800 grams, is now 3000 grams is to 800 grams. We can express this in terms of a fraction as 3000 grams divided by 800 grams. Grams and grams will cancel out, so you have 3000 divided by 800. 3000 divided by 800 will give us 15 divided by 4. This can be expressed in terms of a ratio as 15:4. So the ratio of 3 kilograms to 800 grams is 15:4. We can see from the questions that we have solved in this video that if you want to express two quantities as a ratio in its simplest form, you first have to make sure that both quantities have the same unit of measurement. If they don't have the same unit of measurement, you convert one to the other using the rate of conversion. After that, you express the two quantities as a fraction. Then you cancel out the unit since the unit will be the same. After you have cancelled out the unit, you simplify the resulting fraction to get the ratio. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve questions on ratios involving equations. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved some questions on expressing two quantities as a ratio in its simplest form. In this video, we are going to solve some questions on ratios that involves equations. The questions for this video are: Find the value of x in the following. A. X is to 14 is equal to 28 is to 196. B. 3x is to 5 is equal to 3 is to 1. And C. 4 is to x plus 5 into brackets is equal to 1 is to 2. We will begin with the first one. X is to 14 is equal to 28 is to 196. In the video on Introduction to Ratios, we learned that the ratio A is to B can be written in the form of a fraction as A over B. So if we are applying that here, then the ratio x is to 14 can be written in the form of a fraction as x divided by 14. And the ratio 28 is to 196 can be written in the form of a fraction as 28 divided by 196. This is a linear equation. We are going to solve this linear equation for x. We have one fraction on the left hand side and another fraction on the right hand side. We can multiply both sides of the equation by the LCM of the denominators to cancel out the fraction, or we can simply cross multiply. We learned how to cross multiply in JHS. I'm going to go over it quickly in this video. Let's say that we have this equation A divided by B is equal to C divided by D. We have one fraction on the left hand side, that is A divided by B, and we have one fraction on the right hand side, that is C divided by D. We can simply cross multiply. That is, the numerator on the left hand side will multiply the denominator on the right hand side, and the numerator on the right hand side will multiply the denominator on the left hand side. So first we will have A times D, and this will be equal to B times C. We are going to apply the same thing here. So here we are going to cross multiply. The numerator on the left hand side, which is x, will multiply the denominator on the right hand side, and then the numerator on the right hand side, which is 28, will multiply the denominator on the left hand side, which is 14. So you have x times 196 is equal to 14 times 28. X times 196 will give us 196x. 14 times 28 will give us 392. We will divide the left hand side by 196. We will divide the right hand side by 196. We will have x is equal to 392 divided by 196, and x will give us 2. Let's look at the second question. We have 3x is to 5 is equal to 3 is to 1. As we have learned, the ratio A is to B can be written in the form of a fraction as A divided by B. So the ratio 3x is to 5 can be written in the form of a fraction as 3x divided by 5. And the ratio 3 is to 1 can be written in the form of a fraction as 3 divided by 1. We are going to cross multiply. We have one fraction on the left hand side and another one on the right hand side. So the numerator on the left hand side, which is 3x, will multiply the denominator on the right hand side, which is 1. And then the numerator on the right hand side, which is 3, will multiply the denominator on the left hand side, which is 5. So you will have 3x times 1 is equal to 5 times 3. 3x times 1 will give us 3x. 5 times 3 is 15. We will divide the left hand side by 3. We will divide the right hand side by 3. So x will be equal to 15 divided by 3. And 15 divided by 3 will give us 5. So x is equal to 5. Let's look at the last question. We have 4 is to x plus 5 into brackets is equal to 1 is to 2. The ratio A is to B can be written in the form of a fraction as A divided by B. So the ratio 4 is to x plus 5 can be written in the form of a fraction as 4 divided by x plus 5. And the ratio 1 is to 2 can be written in the form of a fraction as 1 divided by 2. We are going to cross multiply to remove the fraction. So you have the numerator here, which is 4. It will multiply the denominator here, which is 2. Then the numerator here, which is 1, will multiply the denominator here, which is x plus 5. Now this will give us 4 times 2 is equal to 1 times x plus 5. X plus 5 is a binomial, so you will put it in a bracket. You have 1 into bracket x plus 5. 4 times 2 will give us 8. 1 times x will give us x. 1 times 5 will give us 5. So you have 8 is equal to x plus 5. We want to find x, so I'll send 5 to the left hand side, and this will give us 8 minus 5 is equal to x. 5 is positive here, so when it crosses to the left hand side, it's going to be negative. We have 8 minus 5 is equal to x. 8 minus 5 is 3, so 3 is equal to x, or x is equal to 3. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what you've studied in ratios so far to solve practical problems. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we learned how to solve questions on ratios involving equations. In this video, we are going to solve a practical problem involving ratios. The question for this video is: the ratio of Kofi's age to Ama's age is 2:3. Ama is 24 years old. How old is Kofi? We have been given the ratio of Kofi's age to Ama's age as 2:3. And we are being told that Ama is 24 years old. We want to know how old Kofi is. Because we are looking for Kofi's age, let's represent that with a variable. So let's say that Kofi's age is equal to x. In the question, we are told that Ama's age is 24 years. So Ama's age is equal to 24. We are also being told that the ratio of Kofi's age to Ama's age is 2:3. But using Kofi's age as x and Ama's age as 24, we can also find the ratio of Kofi's age to Ama's age. Kofi's age is x and Ama's age is 24. So the ratio of Kofi's age to Ama's age is equal to Kofi's age, which is x, then is to Ama's age, which is 24. So we know from the question that the ratio of Kofi's age to Ama's age is 2:3. And we have also found out that the ratio of Kofi's age to Ama's age is x:24. So we have ratio of Kofi's age to Ama's age as x:24. In the question, we are being told that the ratio of Kofi's age to Ama's age is 2:3. So we can see that they are both the same thing. We can equate them. So the first ratio, that is x:24, is the same as the second ratio, which is 2:3. We have learned that the ratio A:B can be written in the form of a fraction as A divided by B. So the ratio x:24 can be written in the form of a fraction as x divided by 24. The ratio 2:3 can be written in the form of a fraction as 2 divided by 3. So we have x divided by 24 is equal to 2 divided by 3. This is a linear equation. We have to solve it for x. Remember that x is Kofi's age. We learned how to solve this type of linear equation in the previous video. We said that we can multiply both sides of the equation by the LCM of the denominators to cancel out the fractions, or we can simply cross multiply. So by cross multiplying, the numerator here, which is x, will multiply the denominator here, which is 3, and the numerator here, which is 2, will multiply the denominator here, which is 24. So we will have x times 3 is equal to 24 times 2. X times 3 will give us 3x. 24 times 2 will give us 48. We divide the left hand side by 3. We divide the right hand side by 3. And x will be equal to 48 divided by 3, which is 16. So x is equal to 16. But when we started, we said that Kofi's age is equal to x. So if Kofi's age is equal to x and x is equal to 16, then we can say that Kofi is 16 years old. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another practical problem involving ratios. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a practical problem involving ratios. In this video, we are going to solve another practical problem involving ratios. The question for this video is: the ratio of Sandra's age to her father's age is 3:5. The sum of their ages is 96 years. Find their ages. You have been given the ratio of Sandra's age to her father's age as 3:5. We are also being told that the sum of their ages, that is when you add Sandra's age to her father's age, you are going to have 96 years. The question wants us to use these two information to find their ages. So we are going to find how old Sandra is and how old her father is. We are looking for Sandra's age and her father's age. We don't know that, so let's represent that with a variable. Let Sandra's age equal to A and Sandra's father's age equal to B. So now we know that Sandra's age is A and her father's age is B. In the question, we are told that the ratio of Sandra's age to her father's age is 3:5. But using their ages, that is A and B, we can also find the ratio of Sandra's age to her father's age. The ratio of Sandra's age to her father's age will be equal to Sandra's age, which is A, then is to her father's age, which is B. So the ratio of Sandra's age to her father's age is A is to B. In the question, we are told that the ratio of Sandra's age to her father's age is 3:5. So we have the ratio of Sandra's age to her father's age as A is to B, and also the ratio of Sandra's age to her father's age as 3:5. So the first ratio is the same as the second ratio, so we can equate them. The first one is A is to B, and the second one is 3:5. We have A is to B is equal to 3:5. We have learned that the ratio A is to B can be written in the form of a fraction as A divided by B. So you have A divided by B is equal to the ratio 3:5 can also be written in the form of a fraction as 3 divided by 5. Let's cross multiply. So A will multiply 5 and B will multiply 3. A times 5 will give us 5A and B times 3 will give us 3B. This is the first information that the question gave us. The ratio of Sandra's age to her father's age is 3:5. We have been able to use this information to arrive at this equation. 5A is equal to 3B. The second part of the question said that The sum of their ages is 96 years. That means that when you add Sandra's age to her father's age, you should get 96 years. Remember, we have said that Sandra's age is A and her father's age is B. The sum of their ages is 96 years. This means that A, which is Sandra's age, plus B, which is her father's age, should give us 96. So now we have two equations. The first one is 5A is equal to 3B, and the second one is A plus B is equal to 96. We have two equations and two variables, so we are going to solve them simultaneously for the values of A and B. Equation 1 is 5A is equal to 3B, and equation 2 is A plus B is equal to 96. I'm going to use the substitution method. I'll make B the subject in equation 2. So in doing that, B will be equal to 96 minus A. After that, I will substitute B into equation 1. From equation 1, we know that 5A is equal to 3B. But we have seen that B is equal to 96 minus A. So we will replace B here with 96 minus A. This will give us 5A is equal to 3 times 96 minus A is a binomial. We learned in algebra that when you are multiplying a number by a binomial, you put the binomial in a bracket. So you have 5A is equal to 3 times into brackets 96 minus A. This will give us 5A is equal to 3 times 96 will give us 288. 3 times minus A will give us minus 3A. Let's group like terms. So I'll send minus 3A to the left hand side. This will give us 5A plus 3A is equal to 288. We have 5A plus 3A is equal to 288. 5A plus 3A will give us 8A. So 8A is equal to 288. We divide the left hand side by 8. We divide the right hand side by 8. And A is equal to 36 because 288 divided by 8 will give us 36. We made B the subject in equation 2. And we had B is equal to 96 minus A. We have just found out that A is 36. So B will be equal to 96 minus 36. 96 minus 36 will give us 60. So it means that A is equal to 36 and B is equal to 60. Remember that we said A is Sandra's age and B is her father's age. This means that Sandra is 36 years old and her father is 60 years old. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to share a quantity in a given ratio. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a practical problem involving a ratio. In this video, we are going to learn how to share a quantity in a given ratio. Sharing a quantity in a given ratio. Let's consider this example. Kofi and Amma started a business. Kofi contributed 100 Ghana cedis and Amma contributed 200 Ghana cedis. Using this information, we can find the ratio of Kofi's contribution to Amma's contribution. The ratio of Kofi's contribution to Amma's contribution will be equal to Kofi's contribution, which is 100 Ghana cedis, is to Amma's contribution, which is 200 Ghana cedis. We have learned that this ratio, 100 Ghana cedis to 200 Ghana cedis, can be written in the form of a fraction as 100 Ghana cedis divided by 200 Ghana cedis. We can do some cancellation here. Ghana cedis will cancel Ghana cedis. 100 will cancel itself 1 and cancel 200 2 times. So our fraction will now be 1 divided by 2. We have learned that this fraction 1 divided by 2 can be expressed in the form of a ratio as 1:2. So the ratio of Kofi's contribution to Ahmed's contribution is 1:2. Let's learn more. Let's say that Kofi and Ahmed agreed that at the end of each year, they will share the profit made from the business in the ratio of their contribution. So at the end of each year, Kofi and Ahmed have agreed that they are going to share the profit made from the business in the ratio of their contribution. The ratio of their contribution is 1:2. Kofi's part is 1 and Ahmed's part is 2. Using this information, how can we calculate the amount of money Kofi will receive and the amount of money Ahmed will receive? Let's say that at the end of a particular year, let's say 2017, they made a profit of 360 Ghana cedis from the business. We have seen from here that Kofi and Ahmed have agreed that they will share the profit in the ratio of their contribution. So at the end of this year, they are going to use the ratio 1:2 to share the profit, which is 360 Ghana cedis. What will be Kofi's share and what will be Ahmed's share? Kofi's share of the profit will be equal to Kofi's part of the ratio, which is 1, divided by the total ratio, which is 1 plus 2. The total ratio is 1 plus 2 because Kofi's part is 1 and Ahmed's part is 2. So the total will be 1 plus 2 times the total amount of money to be shared, which is 360 Ghana cedis. So Kofi's part of the profit will be equal to Kofi's part of the ratio, which is 1, divided by the total ratio, which is 1 plus 2, times the amount of money to be shared, which is 360 Ghana cedis. And this is equal to 1 divided by 3 times 360 Ghana cedis, which will give us 120 Ghana cedis. In the same way, Ahmed's part of the profit will be equal to Ahmed's part of the ratio, which is 2, divided by the total, which is 1 plus 2, times the amount of money to be shared, which is 360 Ghana cedis. This will give us 2 out of 3 times 360 Ghana cedis, and that will give us 240 Ghana cedis. So as we can see here, when we add Kofi's part of the ratio to Ahmed's part of the ratio, we will get 3. Kofi will receive 1 out of 3 and Ahmed will receive 2 out of 3. So if the total profit to be shared is 360 Ghana cedis, then Kofi's part will be 1 out of 3 times 360 Ghana cedis, and Ahmed's part will be 2 out of 3 times 360 Ghana cedis. So from what we have seen here, we can say that if we are sharing a quantity A among Kofi and Ahmed in the ratio x:y respectively, meaning that Kofi's part is x and Ahmed's part is y. We are sharing a quantity A among Kofi and Ahmed in the ratio x:y respectively. Then Kofi's share will be Kofi's part of the ratio, which will be x, divided by the total, which is x plus y, times the quantity that we are sharing, which is A. Ahmed's share will be equal to Ahmed's part of the ratio, which is y, divided by the total, which is x plus y, times the quantity we are sharing, which is A. This is very, very important. Take note of it because we are going to apply it to solve some questions in the subsequent videos. This type of sharing is what is referred to as proportional sharing. So sharing a quantity in a given ratio is known as proportional division or proportional sharing. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what you have studied in this video to solve a question. Bye-bye. Welcome back. We are still on the topic ratios. In the previous video, we learned how to share a quantity in a given ratio. In this video, we are going to apply what we studied in the previous video to solve a question. The question for this video is: a price of 1,000 Ghana cedis was shared among Ya and Yao in the ratio 2:3 respectively. Find the amount of money received by each one of them. So Ya and Yao shared 1,000 Ghana cedis in the ratio 2:3 respectively. Respectively here means that Ya's part of the ratio is the first one, so Ya's part is 2, and Yao's part of the ratio is the second one, so Yao's part is 3. So the ratio of Ya's share to Yao's share is equal to 2:3. Ya's part is 2 and Yao's part is 3. The total is 5. The question wants us to find the amount of money each one of them received. As we learned in the previous video, Ya's share of the price will be equal to Ya's part of the ratio, which is 2, divided by the total, which is 2 plus 3, times the amount of money that we are sharing, which is 1,000 Ghana cedis. So you have 2 divided by 2 plus 3 times 1,000 Ghana cedis. And this will be equal to 2 divided by 5, since 2 plus 3 is 5. So you have 2 divided by 5 times 1,000 Ghana cedis. 2 divided by 5 times 1,000 Ghana cedis will give us 400 Ghana cedis. So Ya's share of the price is 400 Ghana cedis. Yao's share of the price will be equal to Yao's part of the ratio, which is 3, divided by the total, which is 2 plus 3, times the amount of money we are sharing, which is 1,000 Ghana cedis. This will be equal to 3 divided by 5 times 1,000 Ghana cedis, and this will give us 600 Ghana cedis. So we can see from here that the total ratio is 5. 2 plus 3 will give us 5. Ya's part is 2 and Yao's part is 3. So Ya's share will be equal to 2 out of 5 times the amount of money we are sharing, which is 1,000 Ghana cedis, and that will give us 400 Ghana cedis. And Yao's part of the prize money will be Yao's part of the ratio, which is 3, out of the total, which is 5, times the amount of money we are sharing, which is 1,000 Ghana cedis. So we have 3 divided by 5 times 1,000 Ghana cedis, and this will give us 600 Ghana cedis. So we can say that Yao received 400 Ghana cedis and Yao received 600 Ghana cedis. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is: Kweku and Kwabena are 10 and 12 years old respectively. They shared 30 Ghana cedis in the ratio of their ages. Calculate, correct your answer to the nearest Ghana cedis, the amount of money Kweku received. So we are being told that Kweku and Kwabena are 10 and 12 years old respectively. Respectively here means that the first name corresponds to the first age, and the second name corresponds to the second age. So Kweku is 10 years old and Kwabena is 12 years old. That is the meaning of respectively. The first name corresponds to the first age. The second name corresponds to the second age. Kweku is 10 years old and Kwabena is 12 years old. They shared 30 Ghana cedis in the ratio of their ages. So they shared this 30 Ghana cedis by using the ratio of their ages. The question wants us to calculate and correct our answer to the nearest Ghana cedis, the amount of money Kweku received. Now we are being told that they shared the money by using the ratio of their ages. So the first thing we need to do is to find the ratio of their ages. As we have seen, Kweku is 10 years old and Kwabena is 12 years old. The amount of money they shared is 30 Ghana cedis. The ratio of Kweku's age to Kwabena's age will be equal to Kweku's age, which is 10 years, is to Kwabena's age, which is 12 years. We have seen that this can be written as 10 years divided by 12 years. Years will cancel years, so we will have 10 divided by 12. And 10 divided by 12 will give us 5 divided by 6. We have learnt that the fraction 5 divided by 6 can be expressed in the form of a ratio as 5:6. So the ratio of Kweku's age to Kwabena's age is 5:6. Now we have the ratio. In the question, we are told that they shared 30 Ghana cedis in the ratio of their ages. The ratio of their ages is 5:6. So we are going to use this ratio to find the amount of money Kweku received. The ratio of Kweku's age to Kwabena's age is 5:6. This means that Kweku's part of the ratio is 5 and Kwabena's part is 6. The total is 5 plus 6, which is 11. The total amount of money they shared is 30 Ghana cedis. Kweku's share will be equal to Kweku's part of the ratio, which is 5, divided by the total ratio, which is 5 plus 6, times the amount of money they shared, which is 30 Ghana cedis. This will give us 5 divided by 11 times 30 Ghana cedis. 5 divided by 11 times 30 Ghana cedis will give us 13 Ghana cedis, 63 pesos. But remember that the question said we should correct our answer to the nearest Ghana cedis. So we are going to correct 13.63 to the nearest whole number, and that will give us 14 Ghana cedis. So Kweku's share corrected to the nearest whole number is 14 Ghana cedis. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is: a bag contains red and blue balls only. The ratio of blue to red balls in the bag is 3:5. If there are 152 balls in the bag, how many of them are red? So in a bag, we have only red and blue balls. The ratio of red to blue balls in the bag is 3:5. We are being told that the total number of balls in the bag is 152. The question wants us to find the number of red balls in the bag. So the ratio of blue balls to red balls in the bag is 3:5. The part that belongs to blue balls is 3, and the part that belongs to red balls is 5. The total is 3 plus 5, which is 8. We know that the total number of balls in the bag is 152. We want to find the number of red balls in the bag. The number of red balls in the bag is going to be the part of the ratio that belongs to red balls, which is 5, divided by the total ratio, which is 3 plus 5, times the total number of balls in the bag, which is 152. This will give us 5 divided by 8 times 152, and this will give us 95. So there are a total of 95 red balls in the bag. To find the number of blue balls, is going to be the part of the ratio that belongs to blue balls, which is 3. So that would be 3 divided by the total of the ratio, which is 3 plus 5, times the total number of balls in the bag, which is 152. Or, since the bag contains only red and blue balls, and we have found out that the number of red balls is 95, we can simply subtract 95 from 152 and we will get the number of blue balls. So the part of the ratio that belongs to blue balls is 3. The part that belongs to red balls is 5. The total is 8. So the total number of red balls in the bag will be equal to 5 out of 8 times the number of balls in the bag, and that will give us 95. So we have 95 red balls in the bag. Thank you for watching this video. Subscribe to this channel for more videos. So far, in the examples that we've considered, we have a ratio that has only 2 parts. In the next video, we are going to solve a question that involves a ratio that has 3 parts. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is, Mr. Ansan shared 1,800 Ghana cedis among his 3 daughters, Amma, Esi, and Abna, in the ratio 3:5:7 respectively. Calculate the amount each received. So Mr. Ansan shared 1,800 Ghana cedis among Amma, Esi, and Abna in the ratio 3:5:7 respectively. As I've already explained in the previous videos, when we see respectively at the end of a ratio like this, what it means is that the first name corresponds to the first part of the ratio. The second name corresponds to the second part of the ratio. The third name corresponds to the third part of the ratio. So here, Ama's part of the ratio is 3. Esi's part of the ratio is 5. And Abner's part of the ratio is 7. So the ratio of Ama's share to Esi's share to Abner's share is 3:5:7. The part of the ratio that belongs to Amma is 3. The part of the ratio that belongs to Esi is 5. And the part of the ratio that belongs to Abner is 7. The total is 3 plus 5 plus 7, which will give us 15. The total amount of money shared among them is 1,800 Ghana cedis. The question wants us to calculate the amount of money each one received. Just as we have been doing all along, Ama's share will be equal to Ama's part of the ratio, which is 3, divided by the total ratio, which is 3 plus 5 plus 7, times the total amount of money that was shared, which is 1,800 Ghana cedis. This will give us 3 divided by 15 times 1,800 Ghana cedis. And this is equal to 360 Ghana cedis. So the total ratio is 15. Ama's part of the ratio is 3. So Ama's share will be her part of the ratio, which is 3, divided by the total ratio, which is 15, times the amount of money that was shared, which is 1,800 Ghana cedis. And this will give us 360 Ghana cedis. Let's find Esi's share. Esi's share will be equal to Esi's portion of the ratio, which is 5, divided by the total, which is 3 plus 5 plus 7, times the total amount of money that was shared, which is 1,800 Ghana cedis. This will give us 5 divided by 15 times 1,800 Ghana cedis, and this is equal to 600 Ghana cedis. The total ratio is 15. Esi's part of the ratio is 5. So her share will be 5 out of 15 times the amount of money that was shared, which is 1,800 Ghana cedis, and that will give us 600 Ghana cedis. Finally, Abner's share will be equal to Abner's part of the ratio, which is 7, divided by the total, which is 3 plus 5 plus 7, times the amount of money that was shared, which is 1,800 Ghana cedis. And this will give us 7 out of 15 times 1,800 Ghana cedis. This is equal to 840 Ghana cedis. The total ratio is 15. Abner's part is 7. So her share will be 7 out of 15 times the amount of money that was shared. And that will give us 840 Ghana cedis. So as we have seen, Amma received 360 Ghana cedis, AC received 600 Ghana cedis, and Abner received 840 Ghana cedis. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is: the perimeter of a triangle is 240 centimeters. The length of the sides are in the ratio 3:4:5. Find the length of the longest and shortest sides. So from the question, we are being told that the perimeter of a triangle is 240 centimeters. And the lengths of the sides are in the ratio 3:4:5. The question wants us to use this information to find the longest and shortest sides. To understand this question very well, let's draw the triangle. So let's say that this is the triangle. The length of the shortest side is A, the length of the longest side is C, and the length of the remaining side, that is the side whose length is between A and C, is B. So the length of the shortest side is A, the length of the longest side is C, and the length of the other remaining side is B. From the question, we know that the perimeter of the triangle is 240 centimeters. From the videos on mensuration, we learned that the perimeter of a plane figure is the sum of the distance round the figure. So the perimeter of this triangle is the sum of the distance round the triangle. The shortest side is A, the longest side is C, and the other side is B. So the perimeter of this triangle will be equal to A plus B plus C, and that will give us 240 centimeters. From the question, we are being told that the length of the sides of the triangle are in the ratio 3:4:5. So a triangle has 3 sides. The ratio has 3 parts. The smallest part is 3, the biggest part is 5, and the other part is 4. From our triangle here, we can see that the length of the shortest side is A, the length of the longest side is C, and the length of the other side is B. The sides are in the ratio 3:4:5. What this means is that the length of the shortest side corresponds to 3, since that is the smallest part of the ratio. The length of the longest side will correspond to 5, since that is the biggest part of the ratio. And the length of the other side will correspond to 4, since that is the length of the side that is between A and B. So the shortest side of the triangle, which is A, corresponds to 3, which is the smallest part of the ratio. The longest side of the triangle, which is C, corresponds to 5, which is the biggest part of the ratio. And the other side of the triangle, which is B, corresponds to 4. So A, B, and C are in the ratio 3:4:5. The question wants us to find the length of the longest side and the shortest side. Remember that the perimeter of the triangle is 240 centimeters. So when we add the distance around this triangle together, we will have 240 centimeters. The question wants us to find the length of the longest and shortest side. The longest side is C and the shortest side is A. Let's begin with the longest side. We are finding the length of the longest side, which is C. The length of the longest side, or C, will be equal to the part of the ratio that belongs to C, which is 5, divided by the total ratio, which is 3 plus 4 plus 5, times the total distance around the figure, the perimeter, which is 240 centimeters. This will give us 5 divided by 12 times 240 centimeters. And this is equal to 100 centimeters. So the longest side of the triangle is 100 centimeters. Let's find the shortest side. The shortest side of the triangle is A. So the length of A will be equal to the part of the ratio that belongs to A, which is 3, divided by the total ratio, which is 3 plus 4 plus 5, times the perimeter of the triangle, or the total distance around the triangle, which is 240 centimeters. This will give us 3 divided by 12 times 240 centimeters. And this will give us 60 centimeters. So the length of the shortest side is 60 centimeters. The length of the longest side is 100 centimeters, and the length of the shortest side is 60 centimeters. You can use the same approach to find the length of B. That will be the part of the ratio that belongs to B, which is 4, divided by the total ratio, which is 12, times 240 centimeters. And that will give you the length of B. In the question, we are asked to find the length of the longest side and the shortest side. We have seen that the longest side is 100 centimeters and the shortest side is 60 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is: the interior angles of a triangle are in the ratio 2:1:3. Find the size of each of the interior angles. What type of triangle is this? So the interior angles of a triangle are in the ratio 2:1:3. The question wants us to use this information to find the size of each of the interior angles, and also use the size of the interior angles that you will find to describe the type of triangle we have. So the interior angles of a triangle are in the ratio 2:1:3. Let's draw the triangle to understand this question very well. Let's say that this is the triangle and the interior angles are X, Y, and Z. We are being told in the question that the interior angles are in the ratio 2:1:3. In our triangle here, the interior angles are X, Y, and Z. So X, Y, and Z, which are the interior angles, are in the ratio 2:1:3. This means that the ratio of X to Y to Z will give us 2:1:3. X, Y, and Z are the interior angles. In the question, we are being told that the interior angles of a triangle are in the ratio 2:1:3. So if the interior angles of our triangle are x, y, and z, then it means that x, y, and z are in the ratio 2:1:3. From the videos on mensuration, we learned that in a triangle, the sum of the interior angles is 180 degrees. So that means that in a triangle, when you add all the interior angles together, you should get 180 degrees. So the sum of the interior angles of a triangle is 180 degrees. This means that x plus y plus z will give us 180 degrees. So now we have the sum of the interior angles as 180 degrees. We know that the interior angles are in the ratio 2:1:3. We can use this information to find the value of x, y, and z. That is what the question wants us to do. We are being asked to find the size of each of the interior angles. So let's begin with x. The value of x will be equal to the part of the ratio that belongs to x, that is 2, divided by the total ratio, that will be 2 plus 1 plus 3, times the sum of the interior angles, that is 180 degrees. This will be equal to 2 divided by 6 times 180 degrees, and this will give us 60 degrees. So it means that x is 60 degrees. Let's find y. Y will be equal to the part of the ratio that belongs to y, which is 1, divided by the total ratio, which is 2 plus 1 plus 3, times the sum of the interior angles, which is 180 degrees. And this will give us 1 divided by 6 times 180 degrees, and this will give us 30 degrees. So y is 30 degrees. Remember that we found x to be 60 degrees, and now we have found out that y is 30 degrees. Let's find z. Z will be equal to the part of the ratio that belongs to z, which is 3, divided by the total ratio, which is 2 plus 1 plus 3, times the sum of the interior angles, which is 180 degrees. This will give us 3 divided by 6 times 180 degrees, and this is equal to 90 degrees. So Z will give us 90 degrees. We have been able to find the interior angles of this triangle. We got 30 degrees, 60 degrees, and 90 degrees. X is 60 degrees, so you can replace x with 60 degrees. Y is 30 degrees, so you can replace y with 30 degrees. And z is 90 degrees, so you can replace z with 90 degrees. So now we have answered the first part of the question. We have found the size of each of the interior angles. The next part of the question says that we should describe the type of triangle we have. From the videos on mensuration, we learned that a triangle that has one of its interior angles to be 90 degrees is a right-angled triangle. In this triangle, we have one of the interior angles is 90 degrees. So, since one of the interior angles is 90 degrees, this triangle is a right-angled triangle. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are still on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question on proportional division. The question for this video is, in his will, Mr. Oko left an estate worth $7,600. Out of this, $1,600 was reserved for various purposes. The rest of the amount was shared among his 3 children, Yao, Ekuya, and Nana. Yao received 20% of the amount. The remaining amount was shared between Ekuya and Nana in the ratio 3:2 respectively. Calculate how much each child received. So Mr. Oko left an amount of money of $7,600 in his will. And this was how the money was distributed. $1,600 was set aside or reserved for various purposes. The rest of the money was then shared among his 3 children, Yao, Ekuya, and Nana. Yao was given 20% of the remaining amount, and the amount of money that remained after that was shared between Ekuya and Nana in the ratio 3:2 respectively. We are going to use this information to calculate how much each child received. As we can clearly see in the question, the amount of money Mr. Oko left was $7,600. Out of this, $1,600 was reserved for various purposes. So the amount of money reserved for various purposes is $1,600. This means that the amount of money that was shared among the 3 children will be equal to the amount of money Mr. Oko left, which is $7,600, minus the amount of money that was set aside for various purposes, which is $1,600. And this will give us $6,000. So this $6,000 was shared among Yao, Ekuya, and Nana. So the amount of money shared among the children was $6,000. From the question, we are told that Yao received 20% of this amount. So Yao's share of the money was 20% of $6,000. Yao's share is equal to 20% of the $6,000. From the videos on percentages, we learned that when we see off, we will replace it with multiplication. 20% is the same as 20 divided by 100. So Yao's share is equal to 20 divided by 100 times $6,000. And this will give us $1,200. So the amount of money shared among the 3 children was $6,000, and Yao received $1,200 out of this $6,000. The question continues to tell us that the remaining amount was shared among Ekuya and Nana in the ratio 3:2 respectively. So after Yao received his $1,200, the amount of money that remained was shared among Ekuya and Nana in the ratio 3:2 respectively, meaning that Ekuya's part of the ratio is 3 and Nana's part of the ratio is 2. We have to find the amount of money that was shared between Ekuya and Nana. The amount of money that was shared among the 3 children was $6,000. Yao received $1,200 out of the $6,000. So the amount of money shared between Ekuya and Nana will be equal to the $6,000 minus Yao's share, which is $1,200. And this will give us $4,800. So this $4,800 was shared among Ekuya and Nana. The amount of money shared among Ekuya and Nana was $4,800, and it was shared between them in the ratio 3:2 respectively. This means that the ratio of Ekuya's share to Nana's share is 3:2. Ekuya's part of the ratio is 3 and Nana's part of the ratio is 2. Remember that the amount of money that was shared between Ekuya and Nana was $4,800. So Akuya's share will be equal to Akuya's part of the ratio, which is 3, divided by the total ratio, which is 3 plus 2, times the amount of money that was shared between Akuya and Nana, which is $4,800. This will give us 3 divided by 5 times $4,800, and this is equal to $2,880. So Akuya received $2,880. Nana's share will be equal to Nana's part of the ratio, which is 2, divided by the total ratio, which is 3 plus 2, times the amount of money that was shared, which is $4,800. And this will give us 2 divided by 5 times $4,800, and this is equal to $1,920. So Akuya received $2,880 and Nana received $1,920. So we have been able to find out that Yao received $1,200, Akuya received $2,880, and Nana received $1,920. So Yao, Akuya, and Nana received $1,200, $2,880, and $1,920 respectively. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is: Osei and Nana shared an amount of money in the ratio 3:7 respectively. If Osei received 320 Ghana cedis, calculate I, the amount of money shared, II, the amount of money Nana received. So an amount of money was shared among Osei and Nana in the ratio 3:7 respectively, meaning that Osei's part of the ratio is 3 and Nana's part of the ratio is 7. Osei received 320 Ghana cedis. We are going to use this information to calculate the amount of money that was shared, that is the total amount of money that was shared between Osei and Nana, and the amount of money Nana received. So from the question, we know that the ratio of Osei's share to Nana's share is 3:7, and Osei's share is 320 Ghana cedis. From what we've learned in ratios so far, we know that Osei's share will be equal to Osei's part of the ratio, which is 3, divided by the total ratio, which is 3 plus 7, times the total amount of money that was shared between Nana and Osei. We don't know that total amount of money. That is what we want to find. So let's represent that with a variable. So let P equal to the total amount of money that was shared. Remember, we are told in the question that Osei's share is 320 Ghana cedis. So we know that Osei's share is 320 Ghana cedis, and the total amount of money that was shared between them is P. From the ratio that was given to us in the question, we know that Osei's share is equal to Osei's part of the ratio, which is 3, divided by the total ratio, which is 3 plus 7, times the total amount of money that was shared between Osei and Nana. Osei's share is 320 Ghana cedis, so we can replace Osei's share with 320 Ghana cedis. We have our fraction here, 3 divided by 3 plus 7. 3 plus 7 is 10, so you have 3 divided by 10, times the total amount of money that was shared, which is now P. So we have 320 Ghana cedis is equal to 3 divided by 10 times P. Let's solve this linear equation for P. Our linear equation contains a fraction. So we will multiply both the left-hand side and the right-hand side by the LCM of the denominators. There's only one fraction, so the LCM of the denominator will be the same as the denominator. The denominator of this fraction is 10. So you multiply the left-hand side by 10 and you multiply the right-hand side by 10. 10 and 10 will cancel out. So you have 320 Ghana cedis times 10, which will give us 3,200 Ghana cedis, and 3 times P, which will give us 3P. Let's find P by dividing the left-hand side by 3 and the right-hand side by 3. So P will be equal to 3,200 Ghana cedis divided by 3. And this will give us 1,066 Ghana cedis, 67 pesos. But remember that we said P is the total amount of money that was shared. This means that the total amount of money that was shared was 1,066 Ghana cedis, 67 pesos. So we have now been able to find the total amount of money that was shared. We had 1,066 Ghana cedis, 67 pesos. We can now find Nane's share. We know that the ratio of Osei's share to Nane's share is 3:7. So Nane's share will be equal to Nane's part of the ratio, which is 7, divided by the total ratio, which is 3 plus 7, times the total amount of money that was shared, which is 1,066 Ghana cedis, 67 pesos. This will give us 7 divided by 10 times 1,066 Ghana cedis, 67 pesos. And this is equal to 746 Ghana cedis, 67 pesos. So Nane's share was 746 Ghana cedis, 67 pesos. This is one way of finding Nane's share of the money. We can use another method. We know that the amount of money was shared between Osei and Nana. Osei had 320 Ghana cedis. We have been able to find the total amount of money that was shared to be 1,066 Ghana cedis, 67 pesos. So to find Nane's share, we can simply subtract Osei's share from the total amount of money that was shared. So you have 1,066 Ghana cedis, 67 pesos, minus Osei's share, which is 320 Ghana cedis. And we are going to have the same answer as 746 Ghana cedis, 67 pesos. So you can simply subtract Osei's share from the total amount of money that was shared to get Nane's share, or you can use the ratio to find Nane's share. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is: the ratio of Eric's age to Gina's age is 2:3 respectively. Eric is 24 years old. How old is Gina? So the ratio of Eric's age to Gina's age is 2:3 respectively. This means that Eric's part of the ratio is 2 and Gina's part of the ratio is 3. The total ratio is 5. We are also told that Eric is 24 years old. We are going to use this information that has been given to us to find the age of Gina. So we know that the ratio of Eric's age to Gina's age is 2:3. And we also know that Eric is 24 years old. From what we have learned in ratios so far, we know that Eric's age will be equal to Eric's part of the ratio, which is 2, divided by the total ratio, which is 2 plus 3, times the sum of the ages of Eric and Gina. Eric's age will be equal to Eric's part of the ratio, which is 2, divided by the total ratio, which is 2 plus 3, times the sum of the ages of Eric and Gina. 2 plus 3 is 5. So Eric's age will be equal to 2 divided by 5 times the sum of the ages of Eric and Gina. We don't know the sum of the ages of Eric and Gina. In order to find Gina's age, we have to know the sum of the ages of Eric and Gina. So we are going to represent the sum of the ages of Eric and Gina with a variable. So let A equal to the sum of the ages of Eric and Gina. This means that Eric's age is now equal to 2 divided by 5 times A, since the sum of the ages of Eric and Gina is now A. From the question, we are told that Eric is 24 years old. So Eric's age is equal to 2 divided by 5 times A, where A is the sum of the ages of Eric and Gina. And we know that Eric is 24 years old. This means that 24 is equal to 2 divided by 5 times A. We are going to solve this linear equation for A. It contains a fraction, so you multiply through by the LCM of the denominators. There is only one fraction, so the LCM of the denominator will be the same as the denominator. So you multiply the left hand side by the denominator, which is 5, and you multiply the right hand side by the denominator, which is 5. This will give us 24 times 5 is equal to 5 times 2 divided by 5 times A. 5 and 5 will cancel out. 24 times 5 is 120. 5 and 5 cancels out, so you have 2 times A, which is 2A. You find A by dividing the left hand side by 2 and the right hand side by 2. 120 divided by 2 will give us 60. Here 2 and 2 will cancel out, so you have 60 is equal to A, or A is equal to 60. Remember that we said A is the sum of the ages of Eric and Gina. This means that the sum of the ages of Eric and Gina is 60 years. So now we have the sum of the ages of Eric and Gina as 60 years. The question said that we should calculate the age of Gina. We also know that Eric is 24 years old. So if the sum of the ages of Eric and Gina is 60 years and Eric is 24 years old, then it means that Gina's age will be equal to the sum of the ages of Eric and Gina, which is 60 years, minus Eric's age, which is 24 years, and this will give us 36 years. So we can simply subtract Eric's age from the sum of the ages of Eric and Gina to get Gina's age. Or we can use the ratio as we have been doing all along. We know that the ratio of Eric's age to Gina's age is 2:3. So Gina's age will be equal to Gina's part of the ratio, which is 3, divided by the total ratio, which is 2 plus 3, times the sum of the ages of Eric and Gina. This will be equal to 3 divided by 5 times 60 years, since the sum of the ages of Eric and Gina is 60. 3 divided by 5 times 60 will give us 36 years. So you can see that both methods gives us the same answer. You can simply subtract Eric's age from the sum of the ages of Eric and Gina to get Gina's age, or you can use the ratio to get Gina's age. Both methods gives us the same answer. Gina is 36 years old. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is, in a certain community, the expenditure on roads, schools, and water supply are in the ratio 7:15:2 respectively. If the expenditure on roads is 2,800 Ghana cedis, find I, the expenditure on all the projects, II, the expenditure on schools and water supply. So in this community, the amount of money spent on roads, schools, and water supply are in the ratio 7:15:2 respectively. We are being told that the amount of money spent on roads is 2,800 Ghana cedis. We are going to use this information to find the amount of money spent on all the projects and the amount of money spent on schools and water supply. Okay, so we know that the ratio of the amount of money spent on roads to schools to water supply is 7:15:2 respectively. This means that the part of the ratio that belongs to roads is 7, the part that belongs to schools is 15, and the part that belongs to water supply is 2. We also know that the amount of money spent on roads, that is the expenditure on roads, is 2,800 Ghana cedis. From what we have learnt on ratios, we know that the amount of money spent on roads will be equal to the part of the ratio that belongs to roads, which is 7, divided by the total ratio, which is 7 plus 15 plus 2, times the amount of money spent on all the projects, so the expenditure on all the projects. So the expenditure on roads is equal to 7 divided by 7 plus 15 plus 2 times the expenditure on all the projects. We know that the expenditure on roads is 2,800 Ghana cedis. We want to find the expenditure on all the projects. That is the amount of money spent on all the projects. So let's represent that with a variable. Let y equal to the expenditure on all the projects. As we have seen, the expenditure on roads is 7 divided by 7 plus 15 plus 2 times expenditure on all the projects. We know that expenditure on roads is 2,800 Ghana cedis. So expenditure on roads is 2,800 Ghana cedis. And this is equal to 7 divided by 7 plus 15 plus 2 will give us 24. So 7 divided by 24 times expenditure on all the projects, which is y. So we have 2,800 Ghana cedis is equal to 7 divided by 24 times y. Let's solve this linear equation for y. The equation contains a fraction. So you multiply the left-hand side by the LCM of the denominator and the right-hand side by the LCM of the denominator. We have only one fraction. So the LCM of the denominator will be the same as the denominator. The denominator is 24. So you multiply the left-hand side by 24 and the right-hand side by 24. This will give us 2,800 Ghana cedis times 24 is equal to 24 times 7 divided by 24 times y. 24 and 24 will cancel out. 2,800 Ghana cedis times 24 will give us 67,200 Ghana cedis. As we have seen here, 24 and 24 will cancel, so we have 7 times y, which is 7y. So we have 7y is equal to 67,200 Ghana cedis. We divide the left hand side by 7, we divide the right hand side by 7, and y will give us 9,600 Ghana cedis. But remember that we said y is the expenditure on all the projects. That means that the expenditure on all the projects, or the amount of money spent on all the projects, is 9,600 Ghana cedis. Remember that the expenditure on roads, schools, and water supply are in the ratio 7:15:2 respectively. So the expenditure on schools will be the part of the ratio that belongs to schools, which is 15, divided by the total ratio, which is 7 plus 15 plus 2, which will give us 24, times the amount of money spent on all the projects, which is 9,600 Ghana cedis. This will give us 15 divided by 24 times 9,600 Ghana cedis, and this will give us 6,000 Ghana cedis. This means that the expenditure on schools, or the amount of money spent on schools, is 6,000 Ghana cedis. Let's find the expenditure on water supply. We know that the expenditure on all the projects is 9,600 Ghana cedis. We are given the expenditure on roads in the question as 2,800 Ghana cedis. We have been able to find the expenditure on schools as 6,000 Ghana cedis. So to find the expenditure on water supply, we can simply subtract the expenditure on roads and schools from the expenditure on all the projects to get the expenditure on water supply. So the expenditure on water supply will be equal to 9,600 Ghana cedis minus the expenditure on roads, which is 2,800 Ghana cedis, minus the expenditure on schools, which is 6,000 Ghana cedis. And that will give us the expenditure on water supply. Or you can use the ratio to find it. So the expenditure on water supply will be equal to the part of the ratio that belongs to water supply, which is 2, divided by the total, which is 7 plus 15 plus 2, times the expenditure on all the projects, which is 9,600 Ghana cedis. This will give us 2 divided by 24 times 9,600 Ghana cedis, and this will give us 800 Ghana cedis. So you can use the ratio to find it as you have done here, or you can simply subtract the expenditure on roads and schools from the expenditure on all the projects to get the expenditure on water supply. It doesn't matter which approach you use, you arrive at the same answer, which is 800 Ghana cedis. So we have seen that the expenditure on schools and water supply is 6,800 Ghana cedis respectively. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on proportional division. Bye-bye. Welcome back. We are still on the topic ratios. In the previous video, we solved a question on proportional division. In this video, we are going to solve another question. The question for this video is: 3 businessmen, Yao, Kofi and Kwadwo, entered into a partnership and agreed to share the daily profits made from the business in the ratio of their investment. Yao invested 450 Ghana cedis. Kofi invested 150 Ghana cedis, and Kwadwo invested 600 Ghana cedis. At the end of a particular day, Kwadwo received a profit of 24 Ghana cedis, 70 pesos. Find I, the ratio of the investment of Yao to Kofi to Kwadwo. I, the total profit made from the business on that day. And I, the profit made by Yao and Kofi. So Yao, Kofi and Kwadwo entered into a business agreement or a partnership, and they agreed that at the end of each day, the profit that they will make from the business, they will share it by using the ratio of their investment. Yao invested 450 Ghana cedis. Kofi invested 150 Ghana cedis, and Kwadwo invested 600 Ghana cedis. So using this amount of money that they invested, we can find the ratio of their investment. At the end of one day, Kwadwo received a profit of 24 Ghana cedis, 70 pesos. The question wants us to use this information to find I, the ratio of their investment, I, the total profit that they made on that day, and I, the profit made by Yao and Kofi on that day. So let's begin with the first part, finding the ratio of their investment. We know that Yao invested 450 Ghana cedis, Kofi invested 150 Ghana cedis, and Kwadwo invested 600 Ghana cedis. The question said we should find the ratio of the investment of Yao to Kofi to Kwadwo. So in the ratio, The first one will be for Yao, the second one will be for Kofi, and the third one will be for Kojo. The ratio of the investment of Yao to Kofi to Kojo will be equal to the amount of money Yao invested, which is 450 Ghana cedis, is to the amount of money Kofi invested, which is 150 Ghana cedis, is to the amount of money Kojo invested, which is 600 Ghana cedis. So now we have the ratios as 450 Ghana cedis is to 150 Ghana cedis is to 600 Ghana cedis. They all have the same unit, so we can cancel them out. So you will divide 450 Ghana cedis by Ghana cedis. You will divide 150 Ghana cedis by Ghana cedis, and you divide 600 Ghana cedis by Ghana cedis. So we have Ghana cedis and Ghana cedis cancelling out, Ghana cedis and Ghana cedis cancelling out, and Ghana cedis here and Ghana cedis here cancelling out. Now you'll be left with only the numbers. You have 450 is to 150 is to 600. But we can see that this ratio is not in its simplest form. So we have to break it down to its simplest form. To do that, we will divide each one of them by the highest common factor of these three numbers. So you find the highest common factor of 450, 150, and 600. Then we will divide each one of them by that highest common factor. In JHS, we learned how to find the HCF, or highest common factor of a set of numbers. The highest common factor of 450, 150, and 600 is 150. So you divide each number here by 150. You have 450 divided by 150. You have 150 divided by 150, and 600 divided by 150. 450 divided by 150 will give us 3. 150 divided by 150 will give us 1. 600 divided by 150 will give us 4. Now we have our ratio in its simplest form. So the ratio of the investment of Yao to Kofi to Kojo is 3 is to 1 is to 4 respectively, meaning that Yao's part of the ratio is 3, Kofi's part of the ratio is 1, and Kojo's part of the ratio is 4. So now we have the ratio of the investment of Yao to Kofi to Kojo as 3 is to 1 is to 4 respectively. In the question, we are told that on that day, Kojo received a profit of 24 Ghana cedis, 70 pesos. From what you have learned in ratios, we know that the profit received by Kojo will be equal to the part of the ratio that belongs to Kojo, which is 4, divided by the total, which is 3 plus 1 plus 4, times the total profit made from the business. We want to find the total profit made from the business. So let's represent that with a variable. So let's say that X is equal to the total profit made from the business. As you have seen here, the profit received by Kojo will be equal to the part of the ratio that belongs to Kojo, which is 4, divided by the total ratio, which is 3 plus 1 plus 4, times the total profit made from the business. We know that Kojo received a profit of 24 Ghana cedis, 70 pesos. So the profit received by Kojo is 24 Ghana cedis, 70 pesos. And this is equal to 4 divided by 8, because 3 plus 1 plus 4 will give us 8, times the total profit made from the business, which we have now represented by X. So we have 24 Ghana cedis, 70 pesos is equal to 4 divided by 8 times X. We are going to solve this linear equation for X. We have a fraction, so you multiply the left hand side and the right hand side by the LCM of the denominator. We only have one denominator here, so the LCM will be the same as the denominator. The denominator is 8, so you multiply the left hand side by 8 and the right hand side by 8. This will give us 24 Ghana cedis, 70 pesos times 8 is equal to 8 times 4 divided by 8 times X. 8 and 8 will cancel. 24 Ghana cedis, 70 pesos times 8 will give us 197 Ghana cedis 60 pesos. 8 and 8 will cancel out. We will have 4 times x, and 4 times x will give us 4x. So we have 4x is equal to 197 Ghana cedis 60 pesos. We divide the left hand side by 4 and the right hand side by 4. 4 and 4 will cancel out. 197 Ghana cedis 60 pesos divided by 4 will give us 49 Ghana cedis 40 pesos. Remember that x is the total profit made from the business on that day. So we can say that the profit made from the business on that day was 49 Ghana cedis 40 pesos. We can now find Yao's share and Kofi's share. We know that the ratio of the investment of Yao to Kofi to Kojo is 3:1:4 respectively. So Yao's share will be equal to Yao's part of the ratio, which is 3, divided by the total ratio, which is 3 plus 1 plus 4. That will give us 8 times the total profits made from the business. So we have 3 divided by 8 times 49 Ghana cedis 40 pesos, and this is equal to 18 Ghana cedis 53 pesos. Kofi's share will be equal to Kofi's part of the ratio, which is 1, divided by the total ratio, which is 8, times the total profit made from the business, which is 49 Ghana cedis 40 pesos. So 1 out of 8 times 49 Ghana cedis 40 pesos will give us 6 Ghana cedis 18 pesos. So on that day, Kofi and Yao received a profit of 18 Ghana cedis 53 pesos and 6 Ghana cedis 18 pesos respectively. And the total amount of money they made from the business was 49 Ghana cedis 40 pesos. Thank you for watching this video. Subscribe to this channel for more videos. In the video on Introduction to Ratios, we said that we will learn about ratios and rates. So far, all our attention has been on ratios. In the next video, we are going to focus our attention on the second part of our topic, which is rates. So in the next video, we are going to learn about rates. Bye-bye. Welcome back. We are on the topic ratios and rates. In the previous videos, we have learnt more about ratios. In this video and the subsequent ones, we will concentrate on the second part of our topic, which is rates. So let's learn more about rates. Rates are similar to ratios. In the videos on ratios, we learnt that ratios compare one quantity to another, and the quantities must have the same unit of measurements. We have seen that rates are similar to ratios in that rates also compare one quantity to another. So ratios compare one quantity to another, and rates also compare one quantity to another. But in rates, the quantities that are being compared have different unit of measurement. So in ratios, the quantities that are being compared have the same unit of measurement, but in rates, the quantities that are being compared have different unit of measurement. Let's learn more about rates. Consider this example. In an examination, a student answered 120 questions in 60 minutes. So likely this was an objective test, and in 60 minutes, the student answered 120 questions. We can compare the number of questions the student answered to the time it took the student to answer those questions. In ratios, we learned that the ratio of the questions to time is 120 questions is to 60 minutes. The ratio of the number of questions the student answered to the time it took the student to answer that is 120 questions is to 60 minutes. We learned from ratios that 120 questions is to 60 minutes can be written as 120 questions divided by 60 minutes. We learnt this in ratios. Now, 60 will cancel itself 1 and cancel 120 2 times. So you will have 2 questions divided by 1 minute. Let's separate the numbers from the units. You have 2 divided by 1, then we have questions divided by minutes. 2 divided by 1 will give us 2. Questions divided by minutes will be written as questions per minute. So when we break this down, we will have 2 questions per minute. This means that the student answered 2 questions in every minute. This is an example of a rate. It shows us the number of questions the student answered in a minute. From the example, we are told that he answered 120 questions in 60 minutes. By using ratios, we have been able to break it down to know that the student answered 2 questions per minute. This means that in every minute, the student answered 2 questions. Now let's consider something here. In ratios, we learned that the quantities that are being compared have the same unit of measurement. So when you divide one quantity by the other, the units will cancel out. So the ratio will have no unit. So a ratio does not have a unit. But in rates, the quantities that are being compared have different units of measurement. So after dividing one quantity by the other, the rate will have a unit. In this example, the unit of our rate is questions per minute. We have 2 questions per minute, and as we have seen, it means that the student answered 2 questions in every minute. So when you see 2 questions per minute, what it means is that the student answered 2 questions in 1 minute. Finding this rate is very important because with this rate, we can use it to find the number of questions the student answered when the time changes. We can also use it to find the time that it will take the student to answer a certain number of questions. For example, using this rate, we can use it to find the number of questions the student answered in 3 hours. We can also use it to find the number of questions the student will answer in, let's say, 2 hours or let's say 30 minutes. So using the rate, we can use it to find one quantity when the other quantity changes. Let's consider another example. In 2009, at the IAAF Athletics Championship in Berlin, Usain Bolt completed the 100-meter race in 9.58 seconds. So Usain Bolt ran the 100-meter race in 9.58 seconds. We can compare the distance, which is 100 meters, to the time that it took him to complete that distance, which is 9.58 seconds. The ratio of distance to time is the distance, which is 100 meters, is to the time, which is 9.58 seconds. From ratios, we learned that 100 meters is to 9.58 seconds can be written in the form of a fraction as 100 meters divided by 9.58 seconds. Let's separate the numbers from the units. So you have 100 divided by 9.58 and you have meters divided by seconds. 100 divided by 9.58 will give us 10.4. Meters divided by seconds is written as meters per seconds. So this rate is 10.4 meters per second. Now what this means is that Usain Bolt covered a distance of 10.4 meters in every second. So in 1 second, he covered a distance of 10.4 meters. That is very fast for a human being. a distance of 10.4 meters in every second. As we can see here, we compared the distance that he traveled to the time it took him to travel that distance. When you compare distance to time, the rate that you get is known as speed. So here, 10.4 meters per second is the speed of Usain Bolt. When you compare distance to time, the rate is known as speed. So Usain Bolt's speed in that race was 10.4 meters per second, and that is very, very fast. Finding this rate is also very important because with this rate, we can use it to find the distance when the time changes. So let's say that he keeps on running at this same rate. We can use what we have here, which is 10.4 meters per second, to find the distance that he will travel in, let's say, 2 minutes or let's say 3 minutes. In the same way, we can also use this rate to find the time when the distance changes. So we can use the rate to find the time when the distance changes to, let's say, 400 meters. So let's say that he keeps running at this rate. What will be the time when he has covered a distance of 400 meters? So as you can see, finding the rate is very important because we can use it to find one quantity when there's a change in the other quantity. There are different examples of rates. As I've already indicated here, when we compare distance to time, that rate is known as speed. Another example of rate is density. Density compares mass to volume. So when you compare mass to volume, the rate that you get is known as density. For example, the density of gold is 19.3 gram per centimeter cube. And what this means is that the mass of 1 centimeter cube of gold is 19.3 grams. So if you take 1 centimeter cube of gold and you put it on a measuring scale, you are going to record a mass of 19.3 gram. This is a rate. Now using this rate, we can find the mass when there's a change in volume. We can also find the volume when there's a change in mass. Another example of rate is the rate of pay. The rate of pay compares money to time. Usually, it shows the amount of money an employee will earn in a certain period of time. For example, Kofi is paid 50 Ghana cedis per week. What this means is that Kofi is paid 50 Ghana cedis every week. 50 Ghana cedis per week is known as the rate of pay of Kofi. Using this rate, we can find the amount of money Kofi will earn when the number of weeks changes. So let's say that we want to find the amount of money Kofi will earn in, let's say, 6 weeks. Because we know the rate of pay, we can find that. We can also find the number of weeks it will take Kofi to earn a certain amount of money. So as we have seen from these examples and the previous ones, finding the rate is very important. In the first example, we saw that the student answered 2 questions in a minute. Using this rate, we can find the number of questions when there's a change in the time. We can also find the time when there's a change in the number of questions. In the second example, we saw that the speed of Usain Bolt was 10.4 meters per second. Using this rate, we can find the distance when there's a change in time. We can also find the time when there's a change in distance. In this example here, we have seen that density compares mass to volume. Using the density, we can find the mass when there's a change in volume. We can also find the volume when there's a change in mass. In this example here, we have seen that the rate of pay of Kofi is 50 Ghana cedis per week. Using this rate of pay, we can find the number of weeks it will take Kofi to earn a certain amount of money. We can also find the amount of money Kofi will earn in a certain number of weeks. So basically, this is the main thing that you'll be doing in rates. We will learn how to use a rate to find one quantity when there's a change in the other quantity. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to use a rate to find one quantity when there's a change in the other quantity. Bye-bye. Welcome back. We are on the topic rates. In the previous video, we learned some basic things about rates. In this video, we are going to learn how to use a rate to find one quantity when there's a change in the other. The question for this video is, if 5 meters of a pipe cost 3 Ghana cedis 50 pesos, calculate A, the cost of 10 meters of the pipe, B, the cost of 2 meters of the pipe, and C, the length of pipe Kofi and Ama bought if they paid 5 Ghana cedis and 2 Ghana cedis respectively. So 5 meters of a pipe costs 3 Ghana cedis 50 pesos. Knowing this, the question wants us to find the cost of 10 meters of the pipe and the cost of 2 meters of the pipe and the length of pipe Kofi and Ama bought if they paid 5 Ghana cedis and 2 Ghana cedis respectively. We will solve the first and second part of the question in this video, and we will solve the last part in the next video. Let's begin with the first part. We are going to find the cost of 10 meters of the pipe. From the question, we know that 5 meters of the pipe cost 3 Ghana cedis 50 pesos. So that is the rate. 5 meters cost 3 Ghana cedis 50 pesos. Now, the length has changed from 5 meters to 10 meters. If the length changes from 5 meters to 10 meters, then what will be the new cost? So the rate is 5 meters cost 3 Ghana cedis 50 pesos. The length has changed from 5 meters to 10 meters. So what will be the new cost? Using this rate, we are going to find the new cost when there's the change in the length. In order to use a rate to find one quantity when there's a change in the other, we use two simple principles. The first one is, if more, less divide. And the second one is, if less, more divide. We are going to use these principles throughout our studies in rates, so please pay attention to them. The first one is, if more, less divide. And the second one is, if less, more divide. How do we apply these two principles? Let's come back to our question. We know that the rate is 5 meters cost 3 Ghana cedis 50 pesos. Now, we want to find the cost of 10 meters. So this time we are changing the length. We want to find the new cost. Now you ask yourself, if 5 meters cost 3 Ghana cedis 50 pesos, then 10 meters, will it cost more or less than 3 Ghana cedis 50 pesos? I'll go over it again. The rate is 5 meters cost 3 Ghana cedis 50 pesos. The new length is 10 meters. So you ask yourself, if 5 meters cost 3 Ghana cedis 50 pesos, then 10 meters, will it cost more or less than 3 Ghana cedis 50 pesos? So you think about that. 5 meters cost 3 Ghana cedis 50 pesos. 10 meters, will it cost more or less? You can clearly see that if 5 meters cost 3 Ghana cedis 50 pesos, then 10 meters will cost more than 3 Ghana cedis 50 pesos. It means that we are going to use the first principle. The first principle is for more, and the second principle is for less. So if 10 meters will cost more, then we will use the first principle. The first principle is, if more, less divide. Now that we have established that 10 meters will cost more, less will divide. So among these two lengths, we are going to form a fraction, and the lesser one or the smaller one will divide. So you have 10 meters divided by 5 meters. The principle says that if more, less divide. We have established that it will be more. If it is more, then less will divide. So we will use these two to form a fraction, and the lesser one will divide. That is, the lesser one will become the denominator, and the bigger one will be the numerator. So you have 10 meters divided by 5 meters, since 5 meters is smaller than 10 meters. After that, we will multiply it by the cost. So you have 10 meters divided by 5 meters times the cost. Now you can see from here that we changed the length. So we are going to use the length to form the fraction and multiply it by the cost. If we had changed the cost, we would have used the cost to form the fraction and multiply it by the length. Because here we change the length, we will use the length to form the fraction, and then we will multiply it by the cost. We will have 10 meters divided by 5 meters times 3 Ghana cedis, 50 pesos. So the cost of 10 meters of the pipe will be equal to 10 meters divided by 5 meters times 3 Ghana cedis, 50 pesos. So meters and meters will cancel out, and we will have 10 divided by 5 times 3 Ghana cedis, 50 pesos. 10 divided by 5 will give us 2. 2 times 3 Ghana cedis, 50 pesos will give us 7 Ghana cedis. So the cost of 10 meters of the pipe, or 10 meters of the pipe, will cost 7 Ghana cedis. Let's look at the second part of the question. We are going to find the cost of 2 meters of the pipe. From the question, we know that the rate is 5 meters of the pipe cost 3 Ghana cedis, 50 pesos. So 5 meters cost 3 Ghana cedis, 50 pesos. We want to find the cost of 2 meters. 5 meters cost 3 Ghana cedis, 50 pesos. Now we have changed the length from 5 meters to 2 meters. So the cost is also going to change. We want to find the new cost. We bring back our two principles. The first one is if more, less divide. And the second one is if less, more divide. Now think about it. 5 meters cost 3 Ghana cedis, 50 pesos. We have reduced the length from 5 meters to 2 meters. So will the cost be more or less than 3 Ghana cedis, 50 pesos? When it was 5 meters, the cost was 3 Ghana cedis, 50 pesos. The length has changed to 2 meters. Will it be more or less than 3 Ghana cedis, 50 pesos? We can see that it will be less. If it is less, we are going to apply the second principle. The second principle is for less, and it says that if less, then more will divide. So among these two lengths, that is 5 meters and 2 meters, more will divide. That means that the bigger one will be the denominator and the smaller one will be the numerator. So you will form a fraction with these two lengths, and the bigger one will be the denominator because more is dividing, and the smaller one will be the numerator. So you have 2 meters divided by 5 meters, since 5 meters is bigger than 2 meters. After that, we will multiply it by the cost. So we have 2 meters divided by 5 meters times 3 Ghana cedis, 50 pesos. Once again, we are using the lengths to form the fraction because it was the length that changed. If it had been the cost that changed, we would have used the cost to form the fraction and then multiply it by the length. Here is the length that changed, so we use the length to form the fraction and multiply it by the cost. We have 2 meters divided by 5 meters times 3 Ghana cedis, 50 pesos. This means that the cost of 2 meters of the pipe is 2 meters divided by 5 meters times 3 Ghana cedis, 50 pesos. So meters We'll cancel meters, and that will give us 2 divided by 5 times 3 Ghana cedis 50 pesos. 2 divided by 5 times 3 Ghana cedis 50 pesos will give us 1 Ghana cedi 40 pesos. This means that 2 meters of the pipe will cost 1 Ghana cedi 40 pesos. The last part of our question says that we should find the length of pipe Kofi and Ama bought if they paid 5 Ghana cedis and 2 Ghana cedis respectively. We are going to solve that in the next video. So see you in the next video, and let's continue solving the question. Bye-bye. Welcome back. We started solving this question in the previous video. We solved the first 2 parts. In this video, we are going to solve the last part. The length of pipe Kofi and Ama bought if they paid 5 Ghana cedis and 2 Ghana cedis respectively. From the videos on ratios, we learned that when we see this word respectively, it means that the first quantity is for the first name and the second quantity is for the second name. So it means that Kofi paid 5 Ghana cedis and Ama paid 2 Ghana cedis. We know from the question that the rate is 5 meters of the pipe cost 3 Ghana cedis 50 pesos. Now let's find the length of pipe Kofi bought. After that, we will find the length of pipe Ama bought. So we are going to find the length of pipe Kofi bought if he paid 5 Ghana cedis. We know that 5 meters of the pipe cost 3 Ghana cedis 50 pesos. That's the rate that was given to us in the question. So 5 meters cost 3 Ghana cedis 50 pesos. We are going to find the length if Kofi paid 5 Ghana cedis. So this time, the cost has changed from 3 Ghana cedis 50 pesos to 5 Ghana cedis. That means that the length is going to change. So if Kofi paid 5 Ghana cedis, then what would be the length of pipe that he bought? The 2 principles we are using are if more, less divide, and if less, more divide. So let's think about it. If you pay 3 Ghana cedis 50 pesos, you will get 5 meters of the pipe. Kofi paid 5 Ghana cedis. Will he get more or less than 5 meters? Someone paid 3 Ghana cedis 50 pesos and he got 5 meters. Kofi paid 5 Ghana cedis. Will he get more or less? You can see that if Kofi pays 5 Ghana cedis, then he will get more. If you get more, then you use the first principle. The first principle says that if more, less you divide. Now here, we can see that it is the cost that has changed. So we are going to use the cost to form the fraction. In forming the fraction, less will divide because 5 Ghana cedis will give us more. Less is dividing. So among these two, the lesser one or the smaller one will be the denominator, and the bigger one or the higher one will be the numerator. The lesser one here is 3 Ghana cedis 50 pesos. So you have 5 Ghana cedis divided by 3 Ghana cedis 50 pesos. Then we will multiply it by the length. So here we can see that it is the cost that changed. So you will use the cost to form the fraction, and then we will multiply that fraction by the length. We have 5 Ghana cedis divided by 3 Ghana cedis 50 pesos times 5 meters. So the length of pipe that costs 5 Ghana cedis is equal to 5 Ghana cedis divided by 3 Ghana cedis 50 pesos times 5 meters. Ghana cedis and Ghana cedis will cancel out. So you have 5 divided by 3.50 times 5 meters. 5 divided by 3.50 times 5 meters will give us 7.14 meters. That means that if Kofi paid 5 Ghana cedis, then it means that he bought 7.14 meters of the pipe. Let's find the length of pipe that Amma bought. We know that Amma paid 2 Ghana cedis. From the question, the rate is 5 meters cost 3 Ghana cedis 50 pesos. So 5 meters cost 3 Ghana cedis 50 pesos. And Amma paid 2 Ghana cedis. The two principles we are using are if more, less divide. If less, more divide. So 5 meters cost 3 Ghana cedis 50 pesos. Meaning that if you pay 3 Ghana cedis 50 pesos, you will get 5 meters of the pipe. Amma went to the shop and paid 2 Ghana cedis. Will she get more or less than 5 meters? Someone paid 3 Ghana cedis 50 pesos and got 5 meters. So if Amma paid 2 Ghana cedis, then she will get less. She will get less than 5 meters. If it is less, then you use the second principle. The second principle says that if less, more will divide. Here we can see that it is the cost that changed. So we are going to use the cost to form the fraction. In forming the fraction, we know that more will divide. So among these two, that is 3 Ghana cedis 50 pesos and 2 Ghana cedis, the bigger one will divide. That is, the bigger one will be the denominator and the smaller one will be the numerator. So you have 2 Ghana cedis divided by 3 Ghana cedis 50 pesos. Since 3 Ghana cedis 50 pesos is bigger than 2 Ghana cedis, then we will multiply this by the length. So times the length, which is 5 meters. So the length of pipe that costs 2 Ghana cedis will be equal to 2 Ghana cedis divided by 3 Ghana cedis 50 pesos times 5 meters. Now from here, Ghana cedis and Ghana cedis will cancel out. So you have 2 divided by 3.50 times 5 meters. And this will give us 2.86 meters. This means that if Amma paid 2 Ghana cedis, then she bought 2.86 meters of the pipe. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on using the rate to find one quantity when there is a change in the other. Bye-bye. Welcome back. We are on the topic rates. In the previous video, we solved a question on using a rate to find one quantity when there's a change in the other quantity. In this video, we are going to solve another question. The question for this video is, it took 20 students 12 days to read a school compound. If they read the same compound at the same rate, how many days will it take I, 5 students, I, 30 students? So 20 students were able to read a school compound in 12 days. We want to find the number of days it will take 5 students and 30 students if they read the same compound and they read at the same rate. Let's begin with the first part of our question. So we are going to find the number of days it will take 5 students to read the compound. From the question, we know that 20 students used 12 days to read the compound. So this is our rate. 20 students used 12 days. We want to find the number of days that it will take 5 students. 20 students used 12 days. We want to find the number of days that it will take 5 students. As we saw in the previous video, in order to use a rate to find one quantity when there's a change in the other, we apply two simple principles. The first one is if more, less divide. And the second one is if less, more divide. So you ask yourself, if 20 students use 12 days to read a compound, will 5 students need more than 12 days or less than 12 days? 20 students used 12 days to read the compound. 5 students, would they need more than 12 days or less than 12 days? If you think about it, you will see that the 5 students will need more than 12 days. From our principle, if more, then less will divide. So we are going to use these two to form a fraction. And in the fraction, the lesser one will divide because 5 students will give us more. Between 20 students and 5 students is less. That means that in our fraction, 5 students will be the denominator and 20 students will be the numerator. After that, we will multiply this fraction by the number of days. So we have 20 students divided by 5 students times the number of days, which is 12 days. This means that the number of days used by 5 students will be equal to 20 students divided by 5 students times 12 days. Students and students will cancel out, so you have 20 divided by 5 times 12 days. 20 divided by 5 will give us 4. 4 times 12 days will give us 48 days. So it will take 5 students 48 days to read the compound. Let's look at the second part of our question. How many days will it take 30 students to read the compound? We know that the rate that was given to us in the question is 20 students used 12 days to read the compound. So once again, our rate is 20 students used 12 days. We want to find the number of days it will take 30 students. 20 students used 12 days. Now we have increased the number of students to 30. We want to find the number of days it will take them to read the same compound at the same rate. So you ask yourself once again, if 20 students use 12 days, 30 students, would they need more than 12 days or less than 12 days? It took 20 students 12 days to read the compound. The number of students has now changed to 30. Will those 30 students need more than 12 days or less than 12 days? If you think about it, you can clearly see that the 30 students will need less than 12 days. From our principle, if less, more will divide. So we are going to form a fraction with these two, and more will divide. That is, more will be the denominator and less will be the numerator. So between 20 students and 30 students is more and 20 students is less. We have seen that more will divide. So 30 students will be the denominator and 20 students will be the numerator. So we will have 20 students divided by 30 students. Then we will multiply it by the number of days, so times 12 days. So the number of days used by 30 students will be equal to 20 students divided by 30 students times 12 days. Students and students will cancel out. So you have 20 divided by 30 times 12 days. And this is equal to 8 days. So it will take 30 students 8 days to read the compound. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to use a rate to convert a quantity from one unit of measurement to another. Bye-bye. Welcome back. We are on the topic rates. In the previous video, we solved a question on using a rate to find one quantity when there's a change in the other quantity. In this video, we are going to learn how to use a rate to convert a quantity from one unit of measurement to another. Let's learn how to do that. Converting a quantity from one unit of measurement to another. Let's consider this pipe, which is 10 centimeters long. As we can clearly see, the length of the pipe is in centimeters, which is written in the short form as cm. So the length of this pipe is 10 centimeters. But we know that The length of this pipe can be found in other units apart from centimeters. So the length of this pipe can be written in inches, feet, meters, millimeters, and etc. But in this diagram, the length of the pipe is in centimeters. So what if we want the length of this pipe in another unit apart from centimeters? To do that, we will have to convert 10 centimeters to that unit. So let's say we want the length of the pipe in meters. We will have to convert 10 centimeters to meters. Or let's say we want the length of the pipe in millimeters. We will have to convert 10 centimeters to millimeters. That is what we are going to learn how to do. Let's consider another example. The mass of this box is 25 kilograms. As we can see, the mass of the box is in kilograms, which is written in short form as kg. But we know that mass can be measured in other units like tons or grams. But the mass that we have here is in kilograms. So if we want the mass of this box in tons, we will have to convert 25 kilograms to tons. In the same way, if you want the mass of this box in grams, you have to convert 25 kilograms to grams. We are going to learn how to do that. In order to convert a quantity from one unit of measurement to another, we need the rate of conversion between the two units. In order to convert a quantity from one unit of measurement to another, we need the rate of conversion between the two units. The rate of conversion compares one unit of measurement to another. In JHS, we learned some common rates of conversion. I'm going to go over some of the commonly used ones in this video. We will consider some common rates of conversion for time, distance, mass, and volume. Let's begin with time. Some of the common rates of conversion for time are 1 hour is equal to 60 minutes. 1 hour is equal to 3,600 seconds. 1 day is equal to 24 hours. We can see from these rates of conversion that one unit of measurement of time is being compared to another. So in the first case, we are comparing minutes to seconds, and 1 minute will give us 60 seconds. In the second case, we are comparing hour to minutes. 1 hour is equal to 60 minutes. In the third case, we are comparing hour to seconds, and 1 hour is equal to 3,600 seconds. And in the last one, we are comparing days to hours, and 1 day is equal to 24 hours. Let's consider some common rates of conversion for distance. So for distance, some of the common ones are 1 centimeter is equal to 10 millimeters. 1 meter is equal to 100 centimeters. 1 meter is equal to 1000 millimeters. 1 kilometer is equal to 1000 meters. So in this case also, the rates compare one unit of measurement of distance to another. In the first case, we are comparing centimeters to millimeters, and 1 centimeter is equal to 10 millimeters. Here we are comparing meters to centimeters. 1 meter is equal to 100 centimeters. In the third case, we are comparing meters to millimeters, and 1 meter is equal to 1000 millimeters. And the last one, we are comparing kilometers to meters, and 1 kilometer is equal to 1000 millimeters. Take note that these are not the only rates of conversion for distance and time. I'm just listing some of the commonly used ones. Let's consider some rates of conversion for mass and volume. For mass, the most common one is the rate of conversion between kilograms and grams. 1 kilogram is equal to 1000 grams. For volume, some of the commonly used rates of conversion are 1 meter cube is equal to 1 million centimeter cube. 1 meter cube is equal to 1000 liters. And 1 liter is equal to 1000 centimeters cube. Take note of these rates of conversions because you are going to use them to solve some questions. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what you've learned in this video to solve some questions. Bye-bye. Welcome back. We are on the topic rates. In the previous video, we learned about rates of conversion. In this video, we are going to apply what we studied in the previous video to solve some questions. The question for this video is: convert I 100 kilometers to meters, II 5 centimeters to meters, III 600 meters to kilometers. Let's begin with the first one, 100 kilometers to meters. We learned in the previous video that in order to convert a quantity from one unit of measurement to the other, you need the rate of conversion between those two units of measurements. Here, we want to convert 100 kilometers to meters. So the conversion is between kilometers and meters. So you will need the rate of conversion between kilometers and meters. In the previous video, we considered some rates of conversion. Because we are converting from kilometers to meters, you look through it and find the rate of conversion between kilometers and meters. The rate of conversion between kilometers and meters is 1 kilometer is equal to 1000 meters. So that means that this is the rate of conversion we are going to use. We are converting from kilometers to meters, so we will pick the rate of conversion between kilometers and meters, and that rate is 1 kilometer is equal to 1000 meters. Now we can go ahead and solve our question. So the rate of conversion we are going to use is 1 kilometer is equal to 1000 meters, and we are converting 100 kilometers to meters. 1 kilometer is equal to 1000 meters. This is the standard rate of conversion that we know. We want to convert 100 kilometers to meters. So you ask yourself, if 1 kilometer is giving us 1000 meters, 100 kilometers, will it give us more than 1000 meters or less than 1000 meters? Now think about it. 1 kilometer is giving us 1000 meters. 100 kilometers, will it give us more than 1000 kilometers or less than 1000 kilometers? You can clearly see that it will give us more. If more, let's divide. From our principle, we learned that if more, let's divide. So if 100 kilometers will give us more than 1000 kilometers, then it means that among these two, the lesser one will divide. So you will form a fraction with these two, and the lesser one will divide. The lesser one here is 1 kilometer. So we are going to have 100 kilometers as the numerator, 1 kilometer as the denominator, then we will multiply it by 1000 meters. So we have 100 kilometers divided by 1 kilometer times 1000 meters. Kilometer and kilometer will cancel out. We will have 100 divided by 1 times 1000 meters, and that will give us 100,000 meters. So if we convert 100 kilometers to meters, we will have 100,000 meters. The second part of our question says that we should convert 5 centimeters to meters. We want to convert from centimeters to meters. So you look for the rate of conversion between centimeters and meters. Here are the rates of conversion that we considered in the previous video. We look for the rate of conversion between centimeters and meters, and that is what we have here. We have 1 meter is equal to 100 centimeters. We are converting from centimeters to meters, so you look for the rate of conversion between centimeters and meters, and that is what we have here. 1 meter is equal to 100 centimeters. Now let's use it to solve the question. So our rate is 1 meter is equal to 100 centimeters. Now look at the question. We are converting from centimeters to meters. Because we are converting from centimeters to meters, I prefer writing 100 centimeters on the left hand side, then 1 meter on the right hand side. We have not changed the rate. The rate is 1 meter is equal to 100 centimeters, which is the same as 100 centimeters is equal to 1 meter. But because we are converting from centimeters to meters, I prefer writing the centimeters first. That is the centimeters on the left hand side and the meters on the right hand side. Now we have the rate. 100 centimeters is equal to 1 meter. We are going to convert 5 centimeters to meters. So you ask yourself, 100 centimeters will give us 1 meter. 5 centimeters, will it give us more than 1 meter or less than 1 meter? 100 centimeters is giving us 1 meter. So 5 centimeters, will it be more than 1 meter or less than 1 meter? And you can see that 5 centimeters will give us less than 1 meter. From our principle, if less, more divide. So we will form a fraction with these two and more will divide. That is 100 centimeters will divide, meaning that 100 centimeters will be the denominator and 5 centimeters will be the numerator. So you have 5 centimeters divided by 100 centimeters, then we multiply it by 1 meter, so times 1 meter. Centimeters and centimeters will cancel, so you have 5 divided by 100 times 1 meter, and this will give us 0.05 meters. So 5 centimeters is equal to 0.05 meters. Let's consider the last part of our question. We are converting 600 meters to kilometers. So we are converting from meters to kilometers. Once again, you go through the rate of conversions and you pick the one between kilometers and meters. The one between kilometers and meters, and we have it here. 1 kilometer is equal to 1000 meters. You don't have to necessarily keep on referring to the table. I'm doing that for you to know how the rate of conversion is used. As you solve more questions, you become conversant with them, so you have them off head. Whenever you are converting between one unit and the other, you just write the rate of conversion and you use it. We are converting from meters to kilometers, so we pick the rate of conversion between meters and kilometers, and we have that as 1 kilometer is equal to 1000 meters. So that is the rate we are going to use. 1 kilometer is equal to 1000 meters. We are converting from meters to kilometers. I prefer writing the meters on the left hand side, then kilometers on the right hand side, because we are converting from meters to kilometers. So when I do that, we will have 1000 meters is equal to 1 kilometer. Now we are going to use this rate to convert 600 meters to kilometers. You ask yourself, if 1000 meters is giving us 1 kilometer, 600 meters, will it give us more than 1 kilometer or less than 1 kilometer? 1000 meters is giving us 1 kilometer. 600 meters, will it be more than 1 kilometer or less than 1 kilometer? You can see that it will be less. From the principle, if less, more divide. So you form a fraction with these two and more will divide. That is 1000 meters will be the denominator, 600 meters will be the numerator. Then you multiply it by 1 kilometer. So you have 600 meters divided by 1000 meters times 1 kilometer. Meters and meters will cancel out, so you have 600 divided by 1000 times 1 kilometer, and this will give us 0.6 kilometers. So 600 meters is equal to 0.6 kilometers. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on using the rate of conversion to convert a quantity from one unit of measurement to another. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, We solved a question on using a rate of conversion to convert a quantity from one unit of measurement to another. In this video, we are going to solve another question. The question for this video is: convert I 45 minutes to hours, II 2 hours to minutes, III 2 hours to seconds, and IV 9,000 seconds to hours. Let's begin with the first one. 45 minutes to hours. As we learned in the previous video, in order to convert a quantity from one unit of measurement to another, you will need the rate of conversion between those two units of measurements. Here we have time in minutes, so we have 45 minutes, and we want to convert it from minutes to hours. So we want to convert time from minutes to hours. In order to do that, you will need the rate of conversion between minutes and hours. We have learned that 1 hour will give us 60 minutes. So the rate of conversion between minutes and hours is 1 hour is equal to 60 minutes, or 60 minutes is equal to 1 hour. Because I'm converting from minutes to hours, I'll write the minutes part of the rate on the left hand side, and I'll write the hours part on the right hand side. It's the same as what we have here. 1 hour is equal to 60 minutes, so we can say that 60 minutes is equal to 1 hour. Now we have our rate. We want to convert 45 minutes to hours. So as usual, you ask yourself, if 60 minutes is giving us 1 hour, then 45 minutes, will it give us more than 1 hour or less than 1 hour? 60 minutes is giving us 1 hour, so 45 minutes, will it be more than 1 hour or less than 1 hour? If you think about it carefully, you can see that 45 minutes will give us less than 1 hour. If less, more divide. So you form a fraction with 60 minutes and 45 minutes, and more will divide. Between 60 and 40, 60 is more. So in the fraction, 60 minutes will be the denominator and 45 minutes will be the numerator. So you have 45 minutes divided by 60 minutes times 1 hour. And this will be equal to 45 divided by 60 times 1 hour. This will give us 0.7 hours. So if you convert 45 minutes to hours, you will have 0.75 hours. Let's look at the second question. Convert 2 hours to minutes. So here we are converting from hours to minutes. We will need the rate of conversion between hours and minutes, and that will give us 1 hour is equal to 60 minutes. 1 hour is equal to 60 minutes. We are converting from hours to minutes. So I'll keep the hours part of the rate on the left hand side and the minutes part of the rate on the right hand side. So we have 1 hour is equal to 60 minutes. We want to convert 2 hours. We know that 1 hour will give us 60 minutes. So you ask yourself, 2 hours, will it be more than 60 minutes or less than 60 minutes? You can see that 2 hours will be more than 60 minutes. If more, less we divide. So we form a fraction with 1 hour and 2 hours, and less we divide. That is, 1 hour will be the denominator of the fraction and 2 hours will be the numerator. So we have 2 hours divided by 1 hour times 60 minutes. This will give us 2 divided by 1 times 60 minutes, and this will give us 120 minutes. That means that when we convert 2 hours to minutes, we will have 120 minutes, or 2 hours is equal to 120 minutes. Let's look at the next one. Convert 2 hours to seconds. So this time we are converting from hours to seconds. So you will need the rate of conversion between hours and seconds, and that is 1 hour is equal to 3,600 seconds. So 1 hour will give us 3,600 seconds. We are converting from hours to seconds. So I will keep the hours part of the rate on the left hand side and the seconds part of the rate on the right hand side. We have 1 hour is equal to 3,600 seconds. We are converting 2 hours to seconds. You ask yourself, if 1 hour will give us 3,600 seconds, 2 hours, will it be more than 3,600 seconds or less than 3,600 seconds? If you think about it carefully, you will see that 2 hours will give us more. If more, less will divide. So here, less, which is 1 hour, will divide, and 2 hours will be the numerator. So you have 2 hours divided by 1 hour times 3,600 seconds. This will give us 2 divided by 1 times 3,600 seconds, and this is equal to 7,200 seconds. So it means that 2 hours is equal to 7,200 seconds. Let's look at the last part. Convert 9,000 seconds to hours. So this time we are converting from seconds to hours. We will need the rate of conversion between seconds and hours, and it is 1 hour is equal to 3,600 seconds. We are converting from seconds to hours, so I'll write the seconds part of the rate on the left hand side. So we have 3,600 seconds is equal to, then I'll write the hours part of the rate on the right hand side, and it's equal to 1 hour. So 3,600 seconds is equal to 1 hour. We are converting 9,000 seconds to hours. You ask yourself, if 3,600 seconds gives us 1 hour, 9,600 seconds, will it give us more than 1 hour or less than 1 hour? 3,600 seconds is giving us 1 hour. So 9,600 seconds, will it be more than 1 hour or less than 1 hour? You can clearly see that it will be more than 1 hour. If more, less divide. So less will divide in this fraction. That is 3,600 seconds will be the denominator. Then 9,000 seconds will be the numerator. So we have 9,000 seconds divided by 3,600 seconds times 1 hour. And this is equal to 9,000 divided by 3,600 times 1 hour. This will give us 2.5 hours. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on using a rate of conversion to convert a quantity from one unit of measurement to another. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on using a rate of conversion to convert a quantity from one unit of measurement to another. In this video, we are going to solve another question. The question for this video is: convert 600 grams to kilograms, that is I, 50 kilograms to grams, and I, 200 centimeters cube to liters. Let's begin with the first one. 600 grams to kilograms. As we have learnt in the previous videos, in order to convert a quantity from one unit of measurement to another, you will need a rate of conversion between those two units of measurements. Here, we are converting mass from grams to kilograms. So you need the rate of conversion between grams and kilograms. That rate of conversion is 1 kilogram is equal to 1,000 grams. So you are going to use this rate of conversion to convert 600 grams to kilograms. We are converting from grams to kilograms. So I'll write the grams part of the rate on the left hand side, then I'll write the kilograms part of the rate on the right hand side. So I'll have 1000 grams is equal to 1 kilogram. You can see that nothing has changed here. 1 kilogram is equal to 1000 grams. So 1000 grams is equal to 1 kilogram. Now this is our rate. 1000 grams is equal to 1 kilogram. We are converting 600 grams to kilograms. So as usual, you ask yourself, if 1000 grams is given as 1 kilogram, then 600 grams, will it be more than 1 kilogram or less than 1 kilogram? 1000 grams is given as 1 kilogram. 600 grams, will it be more than 1 kilogram or less than 1 kilogram? As you can see, 600 grams will give us less than 1 kilogram. If less, more divide. So you will have 600 grams as the numerator, then 1000 grams, which is more, will divide. That is, it will be the denominator. So divided by 1000 grams times 1 kilogram. This will give us 600 divided by 1000 times 1 kilogram, and we will have 0.6 kilogram. So 600 grams is equal to 0.6 kilograms. Let's look at the next question. We are converting 50 kilograms to grams. 50 kilograms to grams. So you will need the rate of conversion between kilograms and grams. The rate of conversion, as we have seen, is 1 kilogram is equal to 1000 grams. We are converting from kilograms to grams, so I'll keep kilograms on the left hand side and grams on the right hand side. We have 1 kilogram is equal to 1000 grams. We want to convert 50 kilograms to grams. So if 1 kilogram will give us 1000 grams, 50 kilograms, will it be more than 1000 grams or less than 1000 grams? You can see straight away that 50 kilograms will be more than 1000 grams. If more, less divide. So less will divide here. That is, we will have 50 kilograms at the numerator and 1 kilogram, which is less, at the denominator. So 50 kilograms divided by 1 kilogram times 1000 grams. We will get 50 divided by 1 times 1000, and this is equal to 50,000 grams. So 50 kilograms is equal to 50,000 grams. Let's look at the last part of our question. We are going to convert 200 centimeters cube to liters. In order to do that, we will need the rate of conversion between centimeters cube and liters. The rate of conversion is 1 liter is equal to 1000 centimeters cube. 1 liter is equal to 1000 centimeters cube. So this is the rate that we are going to use. We are converting from centimeters cube to liters. So I'll write centimeters cube on the left hand side and liters on the right hand side. We have 1000 centimeters cube is equal to 1 liter. And we are converting 200 centimeters cube to liters. You ask yourself once again, if 1000 centimeters cube is given as 1 liter, 200 centimeters cube, will it be more than 1 liter or less than 1 liter? 1000 is given as 1 liter. 200, will it be more than 1 liter or less than 1 liter? You can see that 200 will be less than 1 liter. If less, more divide. So in the fraction, 1000 centimeters, which is more, will divide, then 200 centimeters will be the numerator. So we have 200 centimeters cube divided by 1000 centimeters cube times 1 liter. This will give us 200 divided by 1000 times 1 liter, and this is equal to 0.2 liters. So 200 centimeters cube is equal to 0.2 liters. Thank you for watching this video. Subscribe to this channel for more videos. So far, We have learned how to convert a quantity from one unit of measurement to another by using the rate of conversion. In the next video, we are going to learn how to convert an amount of money from one currency to another. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on converting a quantity from one unit of measurement to another. In this video, we are going to learn how to convert an amount of money from one currency to another. Converting an amount of money from one currency to another. A currency is the money used in a country. So the money used in a particular country is known as the currency of that country. For example, in Ghana, the currency is the Ghana cedis, and this is the symbol of the Ghana cedis. In Nigeria, the currency is the Nigerian naira, and this is the symbol. In the USA, the currency is the US dollar, and this is the symbol of the US dollar. In the United Kingdom, their currency is the pound sterling, which is usually referred to as pounds, and this is the symbol of pound sterling. In most European countries like Italy, Germany, and Spain, their currency is the euro, and this is the symbol of the euro. So, the money used in a particular country is referred to as the currency of that country. When you travel from one country to another, you have to convert the money you have to the currency of the country you have visited before you can buy goods or pay for services. I will repeat that. When you travel from one country to another, you have to convert the money you have to the currency of the country you have visited before you can buy goods or pay for services. So, for example, if someone travels from Ghana to Nigeria, the person will have to convert his Ghana cedis to Nigerian naira before he can buy goods or pay for services in Nigeria. In the same way, if someone in the USA sends money to another person in Nigeria, the person will have to convert the money from the US dollar to Nigerian naira before he or she can buy goods or pay for services in Nigeria. This is the reason why it is important for us to learn how to convert money from one currency to another. Because when you leave your country and visit another country, you have to convert your money to the currency of the country you have visited before you can buy goods or pay for services. Now that we know why it is important to learn how to convert money from one currency to another, let's learn how to do it. In order to convert an amount of money from one currency to another, we need the rate of conversion between the two currencies. In the previous videos, we have learned that in order to convert a quantity from one unit of measurement to another, you will need the rate of conversion between those two units of measurements. So, for example, in order to convert time from hours to minutes or minutes to hours, you will need the rate of conversion between hours and minutes, which is 1 hour is equal to 60 minutes. In the same way, in order to convert distance from kilometers to meters or meters to kilometers, you will need the rate of conversion between kilometers and meters, which is 1 kilometer is equal to 1000 meters. We have learnt this in the previous videos. Now, in order to convert an amount of money from one currency to another, we will need the rate of conversion between those two currencies. So, for example, in order to convert an amount of money from Ghana cedis to Nigerian naira, we will need the rate of conversion between the Ghana cedis and the Nigerian naira. This rate of conversion is known as the currency exchange rate. So the rate of conversion between two currencies is known as the currency exchange rate, or simply the exchange rate. Some examples are 1 Ghana cedi is equal to 63.60 naira. Another one is $1 is equal to 5.70 Ghana cedis. The first example is the rate of conversion, or the currency exchange rate between the Ghana cedis and the Nigerian naira. The second example is the rate of conversion, or the currency exchange rate between the US dollar and the Ghana cedis. We can see from these two examples that the currency exchange rate compares the value of one currency to another. So in the first example, we have 1 Ghana cedi is equal to 63.60 naira. What this means is that when we change 1 Ghana cedi into Nigerian naira, we will have 63.60 naira. In the second example, $1 is equal to 5.70 Ghana cedis. What this means is that if we have $1 and we change it to Ghana cedis, we will have 5.70 Ghana cedis. Now, let's learn something very important about currency exchange rates. Due to some economic factors, exchange rates changes from time to time. The rate of conversions that we have considered in the previous videos are constant. They do not change. So for example, 1 hour is always 60 minutes. 1 kilometer is always 1,000 meters. These rates of conversion do not change. They always remain the same. Currency exchange rates are not like that. Due to some economic factors, they keep on changing from time to time. So for example, these exchange rates that we see here are not constant. 1 Ghana cedi is not always 63.60 naira. $1 is not always 5.70 Ghana cedis. It keeps on changing from time to time due to some economic factors. If you want to know these economic factors and how they affect the currency exchange rates, you can read more about the economic factors affecting currency exchange rate online. So you can read more about the factors that causes currency exchange rates to change. Right now, what you have to know is that currency exchange rates are not constant. They keep on changing from time to time. And because of this, whenever you go to the bank to change your money from one currency to another, the current exchange rate is used. So the exchange rate as at the time that you are converting your money will be used for the conversion. If you want to know the current exchange rate between two currencies, you can search online for it. So for example, if you are converting an amount of money from Ghana cedis to Nigerian naira, and you want to know the current exchange rate between the Ghana cedi and the Nigerian naira, you can simply go online and search for exchange rate between Ghana cedis and Nigerian naira, and you are going to have the current exchange rate. And that current exchange rate will be used for the conversion. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned why it is important to know how to convert an amount of money from one currency to another. We have also learned about the currency exchange rates. In the next video, we are going to use a currency exchange rate to convert an amount of money from one currency to another. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we learned some basic things about currency exchange rates. In this video, we are going to use some exchange rates to convert an amount of money from one currency to another. The first question is, given that $1 is equal to 5.54 Ghana cedis, convert $520 to Ghana cedis. So this is the currency exchange rate that has been given to us. $1 will give us 5.54 Ghana cedis. We are going to use this exchange rate to convert $520 to Ghana cedis. Okay, so this is the rate that we have. $1 is equal to 5.54 Ghana cedis. We want to convert $520 to Ghana cedis. We have been doing this all along. The rate given to us is $1 is equal to 5.54 Ghana cedis. And we are converting $520 to Ghana cedis. So you ask yourself, if $1 is giving us 5.54 Ghana cedis, then $520 will it give us more than 5.54 Ghana cedis or less than 5.54 Ghana cedis? $1 is giving us 5.54 Ghana cedis. $520 will it give us more than 5.54 Ghana cedis or less than 5.54 Ghana cedis? You can clearly see that $520 will give us more than 5.54 Ghana cedis. So if more, let's divide. This means that between $1 and $520, less will divide. $1 is less, so $1 will be the denominator, $520 will be the numerator. Then we multiply it by 5.54 Ghana cedis. Dollar and dollar will cancel out, so we have 520 divided by 1 times 5.54 Ghana cedis. 520 divided by 1 times 5.54 Ghana cedis will give us 2,880.80 Ghana cedis. This means that using the rate $1 is equal to 5.54 Ghana cedis, $520 will give us 2,880.80 Ghana cedis. Let's consider the second question. Given that 1 Ghana cedis is equal to 63.64 Nigerian Naira, find the value of 52,000 Naira in Ghana cedis. So we have this rate. 1 Ghana cedis is equal to 63.64 Naira. We are going to use this rate to convert 52,000 Naira to Ghana cedis. Our rate is 63.64 Naira is equal to 1 Ghana cedis, or 1 Ghana cedis is equal to 63.64 Naira. This time we are converting from Naira to Ghana cedis. So I'll write the Naira part of the rate on the left hand side. Then I'll write the Ghana cedis part of the rate on the right hand side. Okay, so we have 63.64 Naira is equal to 1 Ghana cedi. We are converting 52,000 Naira to Ghana cedis. So you ask yourself once again, 63.64 Naira is giving us 1 Ghana cedi. 52,000 Naira, will it give us more than 1 Ghana cedi or less than 1 Ghana cedi? 63.64 Naira is giving us 1 Ghana cedi. 52,000 Naira, will it give us more than 1 Ghana cedi or less than 1 Ghana cedi? You will see that 52,000 Naira will give us more than 1 Ghana cedi. If more, let's divide. Between 63.64 Naira and 52,000 Naira, 63.64 Naira is less, so it means that it's going to divide. That is, it will be the denominator. And 52,000 naira will be the numerator. After that, we multiply it by 1 Ghana cedi, just as we have been doing all along in rates. Naira and naira will cancel out, so we have 52,000 divided by 63.64 times 1 Ghana cedi. 52,000 divided by 63.64 times 1 Ghana cedi will give us 817.10 Ghana cedi. So this means that if we use the rate 1 Ghana cedi is equal to 63.64 naira, then 52,000 naira will give us 817.10 Ghana cedis. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on using a currency exchange rate to convert an amount of money from one currency to another. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on using a currency exchange rate to convert an amount of money from one currency to another. In this video, we are going to solve another question. The question for this video is, given that £1 is equal to 6.64 Ghana cedis and $1 is equal to 5.50 Ghana cedis, find the amount of money Essie has in Ghana cedis if her father and mother sent her £50 and $100 respectively. So Essie's father sent her £50 and her mother sent her $100. The currency exchange rate between pounds and Ghana cedis is £1 is equal to 6.64 Ghana cedis. And the exchange rate between dollars and Ghana cedis is $1 is equal to 5.50 Ghana cedis. We want to find the total amount of money Essie has in Ghana cedis. So it means that we will use the exchange rate between pounds and Ghana cedis to convert £50 to Ghana cedis. Then we will use the exchange rate between dollars and Ghana cedis to convert $100 to Ghana cedis. After that, we add the two. So we know that Essie's father sent her £50 and her mother sent her $100. Let's begin by converting £50 to Ghana cedis. From the rate, we know that £1 is equal to 6.64 Ghana cedis. So £1 is equal to 6.64 Ghana cedis, and we want to convert £50 to Ghana cedis. So you go through the same process you have been doing all along. We know that £1 will give us 6.64 Ghana cedis. So you ask yourself, will £50 be more than 6.64 Ghana cedis or less than 6.64 Ghana cedis? If £1 is giving us 6.64 Ghana cedis, we can see that £50 will give us more than 6.64 Ghana cedis. If more, let's divide. So between £1 and £50, let's divide. £1 is less, so it means that it will be the denominator. £50 is more, so it will be the numerator. Then we multiply it by 6.64 Ghana cedis. This will give us £1 and £1 will cancel, so we have 50 divided by 1, that is 50 times 6.64 Ghana cedis, which is 332 Ghana cedis. So the £50 Essie's father sent her, when you convert it to Ghana cedis by using the rate £1 is equal to 6.64 Ghana cedis, the £50 will give you 332 Ghana cedis. Now let's convert the £100 to Ghana cedis. Okay, so we know that the 50 pounds will give us 332 Ghana cedis. We now have to convert the $100 to Ghana cedis. The rate that was given us was $1 is equal to 5.50 Ghana cedis. So if $1 will give us 5.50 Ghana cedis, will $100 give us more than 5.50 Ghana cedis or less than 5.50 Ghana cedis? $1 is giving us 5.50 Ghana cedis. We can see that $100 will give us more than 5.50 Ghana cedis. If more, let's divide. So between $1 and $100, $1 is less, so it means that we divide. That is, it will be the denominator, and $100 will be the numerator. So we have $100 divided by $1 times 5.50 Ghana cedis. Dollar and dollar will cancel out, so you have 100 divided by 1, which is 100, times 5.50 Ghana cedis, and that will give us 550 Ghana cedis. This means that if we use the rate $1 is equal to 5.50 Ghana cedis, then the $100 Acey's mother sent her will be 550 Ghana cedis. Now remember that Acey's father sent her 50 pounds, and that gave us 332 Ghana cedis. Her mother sent her $100, and that is giving us 550 Ghana cedis. We want to find the total amount of money she has in Ghana cedis. The total amount of money Acey has in Ghana cedis will be the 50 pounds, which is now 332 Ghana cedis, plus the $100, which is now 550 Ghana cedis. 332 Ghana cedis plus 550 Ghana cedis will give us 882 Ghana cedis. So the total amount of money Acey received from her parents was 882 Ghana cedis. Thank you for watching this video. Subscribe to this channel for more videos. Pick more examples on converting an amount of money from one currency to another and try your hands on them. In the video on Introduction to Rates, we learned about some examples of rates. In that video, we considered speed, density, and rate of pay. In the next video and the subsequent ones, we are going to concentrate on speed. So, in the next video, we are going to learn more about speed. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on converting an amount of money from one currency to another. In this video, we are going to learn about speed. Speed. Speed is a rate that compares distance and time. In the video on Introduction to Rates, we learned that a rate compares one quantity to another. Speed is an example of a rate, and speed compares distance and time. To find the speed at which a body is moving, we divide the distance the body has covered by the time it took the body to cover that distance. So we can say that to find speed, we divide distance by time. This is the formula for finding speed. Speed is equal to distance divided by time. Speed is usually measured in meter per second or kilometer per hour. To find speed in meter per second, distance must be in meters and time must be in seconds, so that when you divide them, you have meter per second. In the same way, to find speed in kilometer per hour, distance must be in kilometers and time must be in hours, so that when you divide them, you have kilometer per hour. So to find the speed at which a body is moving, we divide the distance that the body has covered by the time it took the body to cover that distance. Let's consider this example. Let's say that we have 2 points on a straight line, point A and point B. The distance between point A and point B is 60 meters. We have this car at point A and it's going to travel from point A to point B. So the car moves from point A to point B and it covers this distance in a time of 8 seconds. The distance between point A and point B is 60 meters and the car covers this distance in a time of 8 seconds. We can use this information to find the speed at which the car was traveling. To do that, we will divide the distance between point A and point B, which is 60 meters, by the time it took the car to move from point A to point B, which is 8 seconds. So the speed at which this car was moving will give us the distance, which is 60 meters, divided by the time it took the car to move from point A to point B, which is 8 seconds. 60 divided by 8 will give us 7.5. The unit of distance here is meters. The unit of time here is seconds. So the unit of this speed will be meter per second. So the speed at which this car was moving is 7.5 meter per second. There is one very important thing that you have to know about speed. Usually, when a body travels from one point to another, it does not complete the whole journey with a constant speed. To understand this statement very well, let's consider this illustration. We have our car at point A and it's going to move to point B. But this time, instead of moving straight to point B, it will stop at point C, then continue from point C to point B. Let's assume that the distance between point A and point C is 20 meters. From the previous illustration, we know that the distance from point A to point B is 60 meters. So if the distance from point A to point C is 20 meters, then we can say that the distance from point C to point B will be 60 meters minus 20 meters, which is 40 meters. So the distance from point A to point C is 20 meters and the distance from point C to point B is 40 meters. As I said, the car will move from point A to point C and then move from point C to point B. So it moves from point A to point C and it covers this distance of 20 meters in a time of 4 seconds. After that, it moves from point C to point B and it covers this distance in a time of 6 seconds. Now, we know that from point A to point C, the distance is 20 meters and the car covered this distance in a time of 4 seconds. From point C to point B, the distance is 40 meters and the car covered the distance in a time of 6 seconds. Using this information, we can find the speed of the car between point A and point C and then between point C and point B. So between point A and point C, the speed of the car will be the distance, which is 20 meters, divided by the time, which is 4 seconds. 20 divided by 4 will give us 5. The unit here is meters, the unit here is seconds, so you have 5 meter per second. So it means that between point A and point C, the speed of the car was 5 meter per second. In the second part of the journey, that is between point C and point B, the distance was 40 meters and the time was 6 seconds. So the speed of the car there will be 40 meters divided by 6 seconds, and this will give us 6.67 meter per second. So we can see from here that even though the car moved from point A to point B, at different parts of the journey, the speed of the car was different. So from point A to point C, the speed of the car was 5 meters per second. But from point C to point B, the speed of the car was 6.67 meters per second. This was what I was referring to when I said that usually when a body travels from one point to another, it does not complete the whole journey with a constant speed. We can see clearly from this example that even though the body moved from point A to point B, it did not complete the whole journey with a constant speed. From point A to point C, the speed of the car was 5 meters per second. But from point C to point B, the speed of the car was 6.67 meters per second. In this case, if you want to find the speed of the car throughout the entire journey, we will have to find the average speed. In this illustration that we have here, we have the speed of the car at certain portions of the journey. This time, we want the speed of the car throughout the entire journey. To do that, we will have to find the average speed. And the average speed is given by the total distance covered divided by the time taken to cover that distance. So in this case, to find the speed of the car throughout the entire journey, which is the average speed of the car, we will have to divide the total distance the car has covered by the time it took the car to cover that distance. So the average speed of this car will be equal to the total distance. The distance between A and C is 20 meters. The distance between C and B is 40 meters. So the total distance will be 20 meters plus 40 meters divided by the time between point A and point C is 4 seconds. The time between point C and point B is 6 seconds. So 4 seconds plus 6 seconds. This will be equal to 60 meters divided by 10 seconds. 60 divided by 10 is 6. The unit of distance here is meters. The unit of time here is seconds. So you have 6 meters per second. So the speed of the car throughout the entire journey, which is also known as the average speed of the car, was 6 meters per second. So we can clearly see the difference between speed and average speed. Speed gives us the speed of the car at a certain portion of the journey, while average speed gives us the speed of the car throughout the entire journey. Take note of this formula very well. We are going to use it to solve a lot of questions in the subsequent videos. With this formula, we can find the average speed of a body when we know the total distance the body has covered and the time it took the body to cover that distance. In the same way, we can find the total distance that a body has covered when we know the average speed and the time it took the body to cover that distance. We can also use this same formula to find the time that it took a body to cover a certain distance when we know the distance that the body has covered and the average speed at which the body was moving. So we are going to use this formula a lot in the subsequent videos. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what you have studied in this video to solve a question. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we learned about speed. In this video, we are going to apply what we studied in the previous video to solve a question. The question for this video is: a car is traveling at an average speed of 80 kilometers per hour. Find A, the distance covered by the car in 3 hours. B, the time it will take the car to cover a distance of 200 kilometers. So here, the average speed of the car has been given to us as 80 kilometers per hour. We are going to use this average speed to calculate the distance that the car will cover in 3 hours. We also use this speed to calculate the time it will take the car to cover a distance of 200 kilometers. Let's begin with the first part of our question. We know that the average speed of the car is 80 kilometers per hour. We want to find the distance that the car will cover in a time of 3 hours. So for the first part of our question, we are going to find the distance that the car will cover in a time of 3 hours. So time is equal to 3 hours. And from the question, the average speed of the car is 80 kilometers per hour. From the previous video, we learned that average speed is equal to the total distance covered divided by the time. Here, we have been given the average speed of the car. We also know the time, so we are going to substitute this information into this formula to find the distance. We are looking for the distance, so let's represent that with a variable. Let's say that let S equal to the distance covered by the car in 3 hours. So now the average speed of the car is 80 km per hour. The time is 3 hours, and the distance we have represented it with X. Okay, so the average speed is 80 km per hour. The time is 3 hours, and we have represented the distance with S. Let's substitute this information into the formula. Average speed is equal to 80 km per hour. Distance is X, and time is 3 hours. So we have 80 km per hour is equal to X divided by 3 hours. We now have a linear equation. So we are going to solve this linear equation for X, which will give us the distance covered by the car in 3 hours. From linear equations, we know that to find X, we will have to multiply both sides by the LCM of the denominator. The denominator here is 3 hours. So you multiply both sides of the equation by 3 hours. So you have 80 kilometers per hour times 3 hours is equal to X divided by 3 hours times 3 hours. When you do that, we can see that 3 hours and 3 hours will cancel each other out. So 3 hours and 3 hours will cancel each other out. And this will give us 80 kilometers per hour times 3 hours is equal to X. Now, what will 80 kilometers per hour times 3 hours give us? I'm going to explain how the units cancel each other out to you. We know that 80 kilometers per hour can be written as 80 kilometers divided by 1 hour, because 80 divided by 1 will give us 80. Kilometers divided by hour will give us kilometer per hour. So 80 kilometers per hour can be written as 80 kilometers divided by 1 hour. If 80 kilometers per hour can be written as 80 kilometers divided by 1 hour, then 80 kilometers per hour times 3 hours can be written as 80 kilometers divided by 1 hour times 3 hours. So we have 80 kilometers divided by 1 hour times 3 hours. Now when you have this, you will see that hour here and hour here will cancel each other out. So we are going to have 80 kilometers divided by 1, which is 80 kilometers, times 3. 80 times 3 will give us 240. So 80 kilometers times 3 will give us 240 kilometers. So X is equal to 240 kilometers. Remember that in an examination, you don't have to do this. I did this here to explain to you how the units cancel each other out. So the distance x, which is the distance covered by the car in 3 hours, is 240 kilometers. So we can say that the car covered a distance of 240 kilometers in 3 hours. Let's look at the second part of our question. The time it will take the car to cover a distance of 200 kilometers. So we are going to find the time that it will take the car to cover a distance of 200 kilometers. We already know that the car is moving at an average speed of 80 kilometers per hour. And we want the time that it will take the car to cover a distance of 200 kilometers. So distance here is 200 kilometers. We know that average speed is equal to distance covered divided by the time taken to cover that distance. Here we have average speed as 80 kilometers per hour. We have distance as 200 kilometers. So we are going to look for time. Let's represent time with a variable since that is what we are looking for. So let's say that y is equal to the time taken by the car to cover a distance of 200 kilometers. So now we have average speed as 80 kilometers per hour, distance as 200 kilometers, and time as y. We can substitute this information into the formula. So average speed is equal to distance covered divided by the time taken. Average speed is 80 kilometers per hour, distance is 200 kilometers, and time is y. This is now a linear equation. So we are going to solve this linear equation for y. To find y, we multiply the left hand side and the right hand side by y. So we have y times 80 kilometers per hour is equal to 200 kilometers divided by y times y. When you do that, you will see that y and y will cancel each other out here. So you have y times 80 kilometers per hour is equal to 200 kilometers. To find y, we divide the left hand side by 80 kilometers per hour. We divide the right hand side by 80 kilometers per hour. So we have y times 80 kilometers per hour divided by 80 kilometers per hour, and this is equal to 200 kilometers divided by 80 kilometers per hour. So y will be equal to 200 kilometers divided by 80 kilometers per hour. If you are not clear on how to solve this type of linear equation, please watch the video on solving linear equations that is available on this channel. Let's get back to our question. So we have y is equal to 200 kilometers divided by 80 kilometers per hour. Once again, I'm going to explain to you how the units cancel each other out here. 200 kilometers divided by 80 kilometers per hour can be written as 200 kilometers divided by 80 kilometers per hour. In the previous slide, we learned that 80 kilometers per hour can also be written as 80 kilometers divided by 1 hour. So we will have 200 kilometers divided by 80 kilometers divided by 1 hour. From fractions, we have learned that this can be written as 200 kilometers times 1 hour divided by 80 kilometers per hour. We learned this in fractions, so you can watch the videos on fractions to understand this clearly. So we have 200 kilometers times 1 hour divided by 80 kilometers. Now when you do that, you will see that kilometers and kilometers will cancel each other out. 200 here is the same as 200 divided by 1. So you have 200 times 1 hour, which will give us 200 hours, divided by 1 times 80, which will give us 80. 200 divided by 80 will give us 2.5. So 200 hours divided by 80 will give us 2.5 hours. So here y is equal to 2.5 hours. But remember that y is the time that it will take the car to cover a distance of 200 kilometers. So we can say that it will take the car 2.5 hours to cover a distance of 200 kilometers. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on speed. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on speed. In this video, we are going to solve another question. The question for this video is: a car moves steadily for 5 minutes and covers a distance of 60 meters. Calculate the average speed of the car in I, meter per second, II, kilometer per hour. So this car covers a distance of 60 meters in a time of 5 minutes. So the distance covered is 60 meters and the time taken is 5 minutes. We are going to use this information to calculate the average speed of the car in I, meters per second, and II, kilometers per hour. We know that the average speed will be equal to the total distance covered by the car divided by the time taken by the car. Here, we want the average speed in meters per second and in kilometers per hour. For the first part, we are going to find the average speed in meters per second. To do that, the distance covered by the car must be in meters, and the time taken to cover that distance must be in seconds. Here we have the distance covered by the car in meters, so the distance is 60 meters. But the time taken to cover that distance is in minutes. We want the time in seconds, so we will have to convert the time from minutes to seconds. Okay, so the distance is 60 meters and the time is 5 minutes, but we want the time in seconds, so you have to convert time from 5 minutes to seconds. We have learned how to do this, how to convert a quantity from one unit of measurement to another. This time, we are converting time from minutes to seconds. We have learned that to convert a quantity from one unit to another, you will need the rate of conversion between those two units of measurements. We are converting from minutes to seconds, so you need a rate of conversion between minutes and seconds, which is 1 minute is equal to 60 seconds. So this is the rate of conversion. 1 minute is equal to 60 seconds. And we want to find 5 minutes in seconds. So just as we have been doing all along, you ask yourself, if 1 minute is given as 60 seconds, 5 minutes, will it give us more than 60 seconds or less than 60 seconds? You can see that 5 minutes will give us more than 60 seconds. If more, let's divide. So here, 1 minute will divide. That is, 1 minute will be the denominator. 5 minutes will be the numerator. Then we multiply it by 60 seconds. Minutes and minutes will cancel each other out. So we have 5 divided by 1, which is 5, times 60 seconds. And that will give us 300 seconds. So here, 5 minutes is now 300 seconds. Now, we have the distance covered by the car in meters. We have the time taken to cover that distance in seconds. So we can find the average speed of the car in meters per second. We know that the average speed is equal to the total distance covered divided by the time taken. The total distance covered is 60 meters. The time taken in seconds is 300 seconds. 60 divided by 300 will give us 0.2. Meter divided by seconds will give us meter per second. So the average speed of the car is 0.2 meters per second. The second part of our question says that we should find the average speed of the car in kilometers per hour. Let's do that. Remember that in the question, the distance covered by the car was given to us as 60 meters. The time taken to cover that distance was given to us as 5 minutes. We want the average speed of the car in kilometers per hour. In order to get that, the distance must be in kilometers and the time must be in hours. So this time we will have to convert the distance from meters to kilometers. Then we convert the time from minutes to hours. Let's begin with the distance. We are going to convert the distance from meters to kilometers. So we will need the rate of conversion between meters and kilometers. We have learnt that 1000 meters will give us 1 kilometer, or 1 kilometer is equal to 1000 meters. 1000 meters is equal to 1 kilometer. We are going to use this rate to convert 60 meters to kilometers. So if 1000 meters will give us 1 kilometer, then 60 meters, will it give us less than 1 kilometer or more than 1 kilometer? 1000 meters is giving us 1 kilometer. 60 meters will give us less. If less, more divide. So here 1000, which is more, will divide. So you have 60 meters divided by 1000 meters times 1 kilometer. Meters and meters will cancel each other out. We will have 60 divided by 1000 times 1 kilometer, and that will give us 0.06 kilometers. So now we have the distance in kilometers. We want the time in hours, so we have to convert time from minutes to hours. Okay, to do that we need the rate of conversion between minutes and hours. We know that 60 minutes is equal to 1 hour. This is the standard rate of conversion between minutes and hours. 60 minutes, this is 60 minutes, not 60 minutes. So 60 minutes is equal to 1 hour. Okay, so you ask yourself, if 60 minutes is giving us 1 hour, 5 minutes, will it give us more than 1 hour or less than 1 hour? We can see that 5 minutes will give us less than 1 hour. If less, more divide. So here 60 minutes will divide, that is 60 minutes will be the denominator and 5 minutes will be the numerator. Minutes and minutes will cancel each other out. So you have 5 divided by 60 times 1 hour. 5 divided by 60 will give us 1 divided by 12. So you have 1 divided by 12 hours. So 5 minutes will give us 1 divided by 12 hours. Now we have our distance in kilometers and our time in hours. So we can find the speed in kilometers per hour. Okay, so the distance is 0.06 kilometers and the time is 1 divided by 12 hours. We know that average speed is equal to the total distance covered divided by the time taken. And this will be equal to the total distance covered, which is 0.06 kilometers, divided by the time taken, which is 1 divided by 12 hours. We can divide the numbers separately, then we divide the units separately. When we do that, we are going to have 0.06 divided by 1 divided by 12. Kilometers divided by hours will give us kilometers per hour. 0.06 divided by 1 divided by 12 will give us 0.72 kilometers per hour. So the average speed of the car is 0.72 kilometers per hour. So in meters per second, we had 0.2 meters per second, and in kilometers per hour, we are having 0.72 kilometers per hour. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on speed. Bye bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on speed. In this video, we are going to solve another question. The question for this video is: the average speed of a cyclist is 45 meters per second. Calculate I, the average speed of the cyclist in kilometers per hour. II, the distance in kilometers covered by the cyclist after 15 minutes. So the cyclist is moving at an average speed of 45 meters per second. We are going to convert this speed from 45 meters per second to kilometers per hour. After that, we will find the distance in kilometers covered by the cyclist after 15 minutes. So let's begin with the first part. We are going to convert the speed from meters per second to kilometers per hour. So the average speed of the cyclist given to us is 45 meters per second. We have learned that 45 meters per second can also be written as 45 meters divided by 1 second, because 45 divided by 1 will give us 45. Meters divided by a second will give us meters per second. So 45 meters per second can be written as 45 meters divided by 1 second. We want the speed in kilometers per hour. That means that the distance must be in kilometers. So 45 meters must be in kilometers. Then the time must be in hours. So 1 second must be in hours. So all we are going to do now is to convert 45 meters to kilometers. Then we convert 1 second to hours. After that, we can find our speed in kilometers per hour. Okay, so let's begin by converting 45 meters to kilometers. To do that, we need the rate of conversion between kilometers and meters. We know that 1000 meters is equal to 1 kilometer. We are going to convert 45 meters to kilometers. So you ask yourself, if 1000 meters is giving us 1 kilometer, 45 meters, will it give us more or less? 1000 is giving us 1 kilometer. 45 meters will give us less. If less, more divide. So more, which is 1000 meters, will divide. 45 meters will be the numerator. So we have 45 meters divided by 1000 meters. Then we multiply it by 1 kilometer. Meters and meters will cancel each other out. So we have 45 divided by 1000 times 1 kilometer, and that will give us 0.045 kilometers. So we now have our distance in kilometers. We want time in hours. So we are going to convert 1 second to hours. To do that, we need a rate of conversion between seconds and hours. And that rate is 3600 seconds is equal to 1 hour. So 3600 seconds will give us 1 hour. And we want 1 second in hours. So you ask yourself, if 3600 seconds is giving us 1 hour, 1 second, will it be more than 1 hour or less than 1 hour? You can obviously see that 1 second will be less than 1 hour. If less, more divide. So 1 second will be equal to more will divide. So 3600 seconds will divide. 1 second will be the numerator. So we have 1 second divided by 3600 seconds times 1 hour. Seconds and seconds will cancel each other out. So 1 second will be equal to 1 divided by 3,600 hours. So now we have the distance in kilometers, we have the time in hours. We can find the average speed of the cyclist in kilometers per hour. We know that 45 meters per second can be written as 45 meters divided by 1 second. 45 meters is now 0.045 kilometers. 1 second is now 1 divided by 3,600 hours. So 45 meters divided by 1 second is giving us 0.045 kilometers divided by 1 divided by 3,600 hours. We can divide the numbers separately. When we do that, we are going to have 0.045 divided by 1 divided by 3,600. So you do this on your calculator. Kilometers divided by hours will give us kilometers per hour. 0.045 divided by 1 divided by 3,600 will give us 162. So we have 162 kilometers per hour. So the average speed of the cyclist in kilometers per hour is 162 kilometers per hour. This means that when we convert 45 meters per second to kilometers per hour, we are going to have 162 kilometers per hour. We can use our calculator to convert speed from meters per second to kilometers per hour. I'm going to show you how to do that. So first, switch on your calculator. We want to convert 45 meters per second to kilometers per hour. So first you enter 45. We are converting 45 meters per second to kilometers per hour. So you first enter 45 on your calculator. Then you press on shift. After that you press on the 8, number 8. So you press on 8. Now you see the calculator will ask you conversion number 01 to 40. You enter number 20. So you enter 20. As soon as you enter 20, you will have 45 meters per second to kilometers per hour. Then you click equal to, and it's giving us 162. This means that when you convert 45 meters per second to kilometers per hour, we are going to have 162 kilometers per hour, just as our answer gave us. I'm going to go over what I just did once more. So you switch on your calculator. We want to convert 45 meters per second to kilometers per hour. So we enter 45. After that, you press on shift. You press on the 8 button, then you enter the number 20, and that gives us 45 meters per second to kilometers per hour. You press equal to, and we are having 162 kilometers per hour. So let's say if you want to convert 150 meters per second to kilometers per hour, you enter 150, then you press on shift, you press on the 8 button, and you press on 20, and that gives us 150 meters per second to kilometers per hour. You press on equal to, and the calculator will convert for you. Okay, let's continue with our question. This is the first part of our question. We have converted 45 meters per second to kilometers per hour, and we had 162 kilometers per hour. We have also learned how to do this on the calculator. The second part of our question says that we should calculate the distance in kilometers covered by the cyclist after 15 minutes. So this time we are going to calculate the distance covered by the cyclist after 15 minutes. Now we know that the average speed is equal to the total distance covered divided by the time taken. We have average speed in meters per second as 45 meters per second, and in kilometers per hour as 162 kilometers per hour. So which one of these are we going to use? We have average speed in meters per second. We have average speed in kilometers per hour. Which one of them are we going to use? Let's look at the question. We want to calculate for distance in kilometers. If we use the first one, which is meters per second, we are going to have the distance in meters. After that, you will have to convert it to kilometers. But if you use the second one, we will have our distance in kilometers and there will be no need to convert. So it will be advisable to use the second one because in an examination, you want to save time. You can use the first one, which is in meters per second, but after that, you get your distance in meters because here the distance is in meters. The question wants us to find the distance in kilometers. For the second one, the distance is already in kilometers. So if you use it, you are going to get your final answer in kilometers and there will be no need to convert. So I'm going to use 162 kilometers per hour as our average speed. Now let's look at the time. If you use 162 kilometers per hour, then the time must also be in hours. Here we have time in minutes. So because we are going to use 162 kilometers per hour, we have to convert our time from 15 minutes to hours. So we are going to convert time from 15 minutes to hours. To do that, we will need the rate of conversion between minutes and hours. We know that 60 minutes is equal to 1 hour. So if 60 minutes is equal to 1 hour, then 15 minutes will give us less than 1 hour. If less, more divide. So 60 minutes will divide. So we have 15 minutes divided by 60 minutes times 1 hour. Minutes and minutes will cancel each other out. You have 15 divided by 60 times 1 hour. 15 divided by 60 will give us 0.25. So you have 0.25 hours. Okay, so we now have our time in hours. We can find the distance in kilometers. We know that average speed is equal to the total distance covered divided by the time taken. The average speed we are going to use is 162 kilometers per hour. So average speed is 162 kilometers per hour. The total distance covered, that is what we are looking for, divided by the time taken, which is 0.25 hours. This is now a linear equation. Let's solve this linear equation for total distance covered. Okay, so we know that total distance covered divided by 0.25 hours is equal to the average speed, which is 162 kilometers per hour. So we multiply the left hand side by 0.25 hours. We multiply the right hand side by 0.25 hours to remove the fractions. When you do that, you see that 0.25 and 0.25 here will cancel each other out. So you have the total distance covered to be equal to 162 kilometers per hour times 0.25 hours. 162 times 0.25 will give us 40.5. When you multiply kilometers per hour by hours, hour and hour will cancel, so we have kilometers. So the total distance covered by the cyclist will be equal to 40.5 kilometers. So the distance covered by the cyclist in 15 minutes is 40.5 kilometers. Thank you for watching this video. Subscribe to this channel for more videos. The next video, we are going to solve another question on speed. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on speed. In this video, we are going to solve another question. The question for this video is, the average speed of a car is 70 kilometers per hour. Calculate I, the average speed of the car in meters per second. II, the distance in meters covered by the car after 3 hours. So we have been given the average speed of the car to be 70 kilometers per hour. For the first part of the question, we are going to convert the speed from 70 kilometers per hour to meters per second. And for the second part, we will find the distance in meters covered by the car after it has traveled for 3 hours. Let's begin with the first part. We are going to convert the speed from kilometers per hour to meters per second. We know that 70 kilometers per hour can be written as 70 kilometers divided by 1 hour. We want the speed in meters per second. So it means that the distance must be in meters and the time must be in seconds. Here we have the distance in kilometers and the time in hours. So we will convert 70 kilometers to meters, then we convert 1 hour to seconds. I hope that is clear. Let's begin by converting 70 kilometers to meters. We know that 1 kilometer will give us 1000 meters. So if 1 kilometer will give us 1000 meters, what will 70 kilometers give us? 1 kilometer is giving us 1000 meters. So obviously 70 kilometers will give us more than 1000 meters. If more, let's divide. So 70 kilometers will be equal to, less we divide. 1 kilometer is less, so it will be the denominator. 70 kilometers will be the numerator. So we have 70 kilometers divided by 1 kilometer times 1000 meters. Kilometer and kilometer will cancel each other out. So you have 70 divided by 1 times 1000 meters. And that will give us 70,000 meters. So we have converted 70 kilometers to meters and we are having 70,000 meters. Next, we will have to convert 1 hour to seconds. We know that 1 hour is equal to 3,600 seconds. This is the standard rate of conversion. So we have 1 hour in seconds as 3,600 seconds. So we have the distance in meters now, and we have the time in seconds. We can find the speed in meters per second. So 70 kilometers is 70,000 meters. 1 hour is 3,600 seconds. We are going to find the speed in meters per second. As we saw in the previous slide, 70 kilometers per hour can be written as 70 kilometers divided by 1 hour. 70 kilometers is now 70,000 meters. 1 hour is now 3,600 seconds. 70,000 divided by 3,600 will give us 19.44. Meters divided by seconds will give us meters per second. So 70 kilometers per hour will give us 19.44 meters per second. So we can say that the average speed of the car in meters per second is 19.44 meters per second. So if you convert 70 kilometers per hour to meters per second, you are going to have 19.44 meters per second. In the previous video, we learned how to use our calculator to convert speed from meters per second to kilometers per hour. This time, we have the speed in kilometers per hour. So we are going to learn how to use the calculator to convert it from kilometers per hour to meters per second. So you switch on your calculator once again. We are converting 70 kilometers per hour to meters per second. So first you enter the number we are converting, which is 70. Then you press on Shift. You press on the 8 button. We have to enter the conversion number. In the previous video, the conversion number was 20. We were converting from meters per second to kilometers per hour. The conversion number for that is 20. If you are converting from kilometers per hour to meters per second, the conversion number is 19. So this time we enter the conversion number, which is 19. And we have 70 kilometers per hour to meters per second. We press equal to, and this is giving us 19.44, just as we have here. I'm going to repeat it once more. So you should show your calculator. We are converting 70 kilometers per hour to meters per second. So you enter the number we are converting, which is 70. Then you press on shift, you press on the 8 button, and you enter the conversion number. The conversion number for kilometers per hour to meters per second is 19. So you enter 19, and we will have 70 kilometers per hour to meters per second. You enter equal to, and we are having 19.44. Let's get back to our question. So for the first part, we have been able to convert 70 kilometers per hour to meters per second. The second part says that we should find the distance in meters covered by the car after 3 hours. We know that average speed is equal to the total distance covered divided by the time taken. We are going to find the distance covered after 3 hours. We have average speed and time. The time is now 3 hours. So we want the distance after 3 hours. So time is 3 hours. We have average speed in kilometers per hour and meters per second. So we know that in kilometers per hour, the average speed of the car is 70 kilometers per hour. In meters per second, the average speed of the car is 19.44 meters per second. So which one are we going to use? Now let's look at the question very carefully. We are looking for the distance in meters covered by the car after 3 hours. So the time here is 3 hours. If we use the first one, we will not have to convert the time because the time here is in hours. We have 70 kilometers per hour, so the time here is in hours. But after we have used this, we will have our distance in kilometers. The question wants us to give our distance in meters. So after having the distance in kilometers, we will have to convert it from kilometers to meters. That is when we use the first one. We will not have to convert the time, but we will get our answer in kilometers because here the distance is in kilometers. So we will then have to convert from kilometers to meters. When we use the second one, we are going to get our distance in meters, just as we have here. But we will have to convert the time to seconds because here we have 19.44 meters per second. The time is in seconds, so you have to convert 3 hours to seconds. After we have converted 3 hours to seconds, we will use this average speed to get our distance in meters. So you can use any of them. For the first one, we will not have to convert the time because we already have the time in hours. The time here is already in hours. But after we get our answer, we will have to convert the distance from kilometers to meters. For the second one, we will have to convert our time to seconds because the time here is in seconds. But after that, we will have our distance in meters. So in each case, you are going to convert. So I'm going to use the first one, which is 70 kilometers per hour. You can also try the second one. You will see that you get the same answer. But in this video, I'm going to use the first one, which is 70 kilometers per hour. So our speed is 70 kilometers per hour. The time is in hours already, so we don't have to convert because we have the time here in hours. We are looking for the total distance covered. So 70 kilometers per hour is equal to the total distance covered divided by 3 hours. We multiply the left hand side by 3 hours. We multiply the right hand side by 3 hours to cancel out the fractions. So 3 hours here we'll cancel out 3 hours. So we have 3 hours times 70 kilometers per hour equal to the total distance covered. 3 hours times 70 kilometers per hour will give us 210 kilometers, because hours and hours will cancel each other out. So you have 3 times 70 kilometers, which is 210 kilometers. So the total distance covered is 210 kilometers. But the question said we should look for the total distance covered in meters. What we have here is in kilometers. So we will now have to convert the distance from kilometers to meters. So you have to convert 210 kilometers to meters. We have the distance as 210 kilometers. We are going to convert it to meters. We know that 1 kilometer is equal to 1,000 meters. We are going to convert 210 kilometers. If 1 kilometer is given as 1,000 meters, 210 kilometers will give us more than 1,000 meters. If more, let's divide. So we have 210 kilometers divided by 1 kilometer times 1,000 meters. Kilometer and kilometer will cancel each other out. You have 210 times 1,000 meters, and that will give us 210,000 meters. So the distance covered by the car in 3 hours is 210,000 meters. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on speed. Bye bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on speed. In this video, we are going to solve another question. The question for this video is: two passenger trains A and B, 450 kilometers apart, start to move towards each other at the same time and meet after 2 hours. If train B travels 8 divided by 7 as fast as the train A, find the speed of each train. To understand this question very well, let's consider this illustration. So we have two passenger trains, train A and train B. Let's say that train A is at point A and train B is at point B. From the question, we are being told that the two passenger trains, that is train A and train B, are 450 kilometers apart. This means that the distance between the position of point A and the position of point B is 450 kilometers. The distance between them is 450 kilometers. So from point A to point B is 450 kilometers. Now the question goes on to tell us that these two trains start to move towards each other at the same time. So these two trains start moving towards each other at the same time. So they move towards each other at the same time, and after 2 hours they meet at a point. So let's say that after 2 hours these two trains meet at this point. We are going to call that point M. I hope that is clear. The distance between the two trains is 450 kilometers. They start to move towards each other and meet at a point after 2 hours. So after 2 hours, train A will travel from point A to point M, that is the meeting point. And after 2 hours, train B will travel from point B to point M, that is the meeting point. Okay, let's call the distance between point A and point M, that is the distance traveled by train A after 2 hours. Let's call that distance X. And the distance between point M and point B, that is the distance traveled by train B after 2 hours. Let's call that distance Y. So the distance traveled by train A after 2 hours is x, and the distance traveled by train B after 2 hours is y. From the diagram, we can clearly see that x plus y will give us 450 kilometers. So when we add the distance traveled by train A to the distance traveled by train B, you get 450 kilometers. The question goes on to tell us that train B travels 8 divided by 7 as fast as the train A. This means that if we multiply the speed of train A by 8 divided by 7, we will get the speed of train B. The question wants us to use this information to find the speed of each train. Okay, so now that we understand the question, let's go on with the solution. From the question, we were told that train A and train B are 450 kilometers apart. So from point A to point B is 450 kilometers. We can see from the diagram that from point A to point M is x, and from point M to point B is y. So if we add x and y, we are going to get 450 kilometers. So x plus y is equal to 450 kilometers. Let's call this equation 1. The question also tells us that train B travels 8 divided by 7 as fast as the train A. This means that if you want the speed of train B, you will have to multiply the speed of train A by 8 divided by 7. So speed of train B is equal to 8 divided by 7 times the speed of train A. Now we will have to find the speed of train B and the speed of train A. We have learnt that speed is equal to distance divided by time. So the speed of train A will be equal to the distance covered by train A divided by the time taken to cover that distance. And likewise, the speed of train B will be the distance covered by train B divided by the time taken to cover that distance. Remember that from the question, we were told that these two trains met after 2 hours. So it means that both trains have covered a distance in a time of 2 hours. So the time for train A is 2 hours and the time for train B is 2 hours. From the diagram, we can see that the distance covered by train A is x and the distance covered by train B is y. So the speed of train B will be equal to the distance covered by train B, which is y, divided by the time taken to cover that distance, which is 2 hours. The speed of train A will be equal to the distance covered by train A, which is x, divided by the time taken to cover that distance, which is 2 hours. So the speed of train B is y divided by 2 hours, and the speed of train A is x divided by 2 hours. Let's substitute this information into our equation. Speed of train B is y divided by 2 hours. We have 8 divided by 7 times speed of train A is x divided by 2 hours. So we have y divided by 2 hours is equal to 8 divided by 7 times x divided by 2 hours. Let's cancel 2 hours out of our equation. So let's multiply the left hand side by 2 hours and the right hand side by 2 hours. So you have 2 hours times y divided by 2 hours is equal to 8 divided by 7 times x divided by 2 hours times 2 hours. When you do that, you can see that 2 hours and 2 hours will cancel each other out here. 2 hours and 2 hours will cancel each other out here. So you'll be left with y here. So y will be equal to, we have 8 divided by 7. 2 hours and 2 hours are gone. So you'll be left with x. So 8 divided by 7 times x. And this will give us 8. Y is equal to 8 divided by 7 x. We are going to call this equation 2. Remember that we had equation 1 as x plus y is equal to 450 kilometers. And we are having equation 2 as y is equal to 8 divided by 7x. We have two equations and two variables, so we are going to solve them simultaneously. Equation 1 is x plus y is equal to 450 kilometers. Equation 2 is y is equal to 8 divided by 7x. Y is already the subject in equation 2, so we can easily substitute it into equation 1. We have solved more examples on solving simultaneous linear equations. If you want to understand how to solve simultaneous linear equations, watch the videos on solving simultaneous linear equations that is available on this channel. So we are going to go ahead with our solution here. We are going to substitute equation 2 into equation 1. And we will have x plus y, which is 8 divided by 7x, is equal to 450 kilometers. Let's multiply through this equation by 7. So we have 7 times x plus 7 times 8x divided by 7 is equal to 7 times 450 kilometers. We multiply through by 7 to remove the fraction. We learnt this under linear equations. 7 times x will give us 7x. From algebra, we know that 7 times x is 7x. 7 and 7 here will cancel out, so you will be left with 8x, and this is equal to 7 times 450 kilometers will give us 3,150 kilometers. 7x plus 8x will give us 15x. So we have 15x is equal to 450 kilometers. We want to find x, which is the distance covered by train A after 2 hours. So we have 15x is equal to 3,150 kilometers. To find x, we divide the left hand side by 15, we divide the right hand side by 15. So we divide the left hand side here by 15, then we divide the right hand side here also by 15. Now you see that 15 and 15 will cancel each other out, so you are going to have x is equal to 3,150 kilometers divided by 15. 3,150 kilometers divided by 15 will give us 210 kilometers. This means that after 2 hours, train A covered a distance of 210 kilometers. Now let's find y, which is the distance covered by train B after 2 hours. From equation 2, we know that y is equal to 8 divided by 7x. We have found x to be 210 kilometers. So we can replace x with 210 kilometers. So y will be equal to 8 divided by 7 times 210 kilometers. And this will give us 240 kilometers. Remember that y is the distance covered by train B after 2 hours. So it means that after 2 hours, train B had covered a distance of 240 kilometers. The question said that we should calculate the speed of train A and train B. We now have x, which is the distance covered by train A after 2 hours, and y, which is the distance covered by train B after 2 hours. So we have the distance and we have time. We can calculate for speed. So the speed of train A will be equal to the distance, which is x, divided by the time, which is 2 hours. X is now 210 kilometers. So the speed of train A will be 210 kilometers divided by 2 hours. 210 divided by 2 will give us 105. Kilometer divided by hour will give us kilometer per hour. So we can say that the speed of train A was 105 kilometers per hour. In the same way, we can find the speed of train B. The speed of train B will be the distance covered by train B, which is y, divided by the time, which is 2 hours. Y is 240 kilometers. So the speed of train B will be equal to 240 kilometers divided by 2 hours. 240 divided by 2 will give us 120. Kilometers divided by hours will give us kilometer per hour. So it means that the speed of train B was 120 kilometers per hour. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on speed. Bye-bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on speed. In this video, we are going to solve another question. The question for this video is: a motorist traveled 20 kilometers at an average speed of 15 kilometers per hour. If he made the return journey at an average speed of 30 kilometers per hour, find the average speed of the whole journey. To help us understand this question, let's consider this illustration. So we have the motorist here, and this is the starting point. Let's call this point A, and let's call his destination or the ending point point B. From the question, we are told that the motorist traveled a distance of 20 kilometers. So the distance between where he started and where he ended was 20 kilometers. So the distance between A and B is 20 kilometers. And he traveled at a speed of 15 kilometers per hour. So the motorist moved from point A to point B. The distance between point A and point B is 20 kilometers. And the speed at which he was traveling was 15 kilometers per hour. So the average speed was 15 kilometers per hour. This was the first part of the journey. After that, the motorist made the return journey. That is, he turned back to his starting position. So he returned to where he started from. This time, he moved at a speed of 30 kilometers per hour. But look at something here. When he was returning, he covered the same distance. The distance didn't change. So for the return journey, the distance will be the same as the starting journey. The distance for the second part of the journey will be the same as the distance for the first part of the journey, because the second part of the journey was a return journey, so the distance doesn't change. But the average speed was different. For the second part of the journey, the average speed was 30 kilometers per hour. We have seen that the distance will be the same since it was the return journey, so the distance is still 20 kilometers. We are going to use this information to find the average speed of the whole journey. Now look at something. To find the average speed of the whole journey, we will need the total distance covered by the motorist. We have seen that the journey was in two parts. In the first part, he covered a distance of 20 kilometers. Then the second part was the return journey. He covered another distance of 20 kilometers. So the total distance covered by the motorist will be the 20 kilometers for the first part of the journey plus the 20 kilometers for the second part of the journey. So you have 20 kilometers plus 20 kilometers, and that will give us 40 kilometers. That will be the total distance covered throughout the entire journey. Now we will have to divide it by the time taken to cover this distance. That is what we'll be looking for. So first, we will have to find the time taken to cover the first part of the journey and the time taken to cover the second part of the journey. we have average speed and distance. So we can calculate the time for the first part of the journey. For the second part also, we have average speed and distance. So we can calculate the time. So let's begin with our calculation. Now, we know that for the first part of the journey, the average speed was 15 kilometers per hour and the distance was 20 kilometers. We are looking for the time. So let's represent the time with a variable x. We know that average speed is equal to total distance covered divided by time taken. Average speed is 15 kilometers per hour, distance is 20 kilometers, and time is x. So let's solve for x. So we have 15 kilometers per hour is equal to 20 kilometers divided by x. We multiply the left hand side by x, we multiply the right hand side by x to remove the fraction. So we have x times 15 kilometers per hour is equal to 20 kilometers divided by x times x. X and x will cancel out. So we have x times 15 kilometers per hour is equal to 20 kilometers. We divide the left hand side by 15 kilometers per hour. We divide the right hand side by 15 kilometers per hour. So x will be equal to 20 kilometers divided by 15 kilometers per hour. 20 divided by 15 will give us 4 divided by 3. Kilometers and kilometers will cancel each other out. So we will be left with hours. So x is equal to 4 divided by 3 hours. So we can see that for the first part of the journey, it took the motorist 4 divided by 3 hours to cover the 20 kilometers. Now, let's calculate the time taken by the motorist to cover the second part of the journey. For the second part of the journey, we know that the average speed was 30 kilometers per hour, but the distance is still 20 kilometers. Once again, we are looking for time. Let's represent that with y. So average speed, which is 30 kilometers per hour, will be equal to the distance, which is 20 kilometers, divided by the time, which is now y. We multiply the left hand side by y, we multiply the right hand side by y. Y and y will cancel each other out. So we have y times 30 kilometers per hour is equal to 20 kilometers. We divide the left hand side by 30 kilometers per hour. We divide the right hand side by 30 kilometers per hour. 30 kilometers per hour and 30 kilometers per hour will cancel each other out. 20 divided by 30 will give us 2 divided by 3. Kilometers and kilometers will cancel each other out. So y will be equal to 2 divided by 3 hours. So this means that for the second part of the journey, it took the motorist 2 divided by 3 hours to cover the 20 kilometers. Now, we have the total distance for both the first and second part of the journey, and we also have the time for both the first and second part of the journey. So we can find the average speed for the whole journey. Average speed for the whole journey will be the total distance covered divided by the total time taken. The total distance covered will be the distance for the first part of the journey, which was 20 kilometers, plus distance for the second part of the journey, which was 20 kilometers, divided by time for the first part of the journey, which was 4 divided by 3 hours, plus time for the second part of the journey, which was 2 divided by 3 hours. 20 kilometers plus 20 kilometers will give us 40 kilometers. 4 divided by 3 plus 2 divided by 3 will give us 2. So 4 divided by 3 hours plus 2 divided by 3 hours will give us 2 hours. 40 divided by 2 will give us 20. Kilometer divided by hour will give us kilometer per hour. So 40 kilometers divided by 2 hours will give us 20 kilometers per hour. So we can say that the average speed of the motorist for the whole journey was 20 kilometers per hour. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on speed. Bye bye. Welcome back. We are still on the topic rates. In the previous video, we solved a question on speed. In this video, we are going to solve another question on speed. The question for this video is: a cyclist travels for 2 hours at an average speed of 35 kilometers per hour. Then, for 3 hours at an average speed of 45 kilometers per hour. What is her average speed for the whole journey? So the cyclist made a journey in two parts. For the first part, she traveled for 2 hours at an average speed of 35 kilometers per hour. And for the second part, she traveled for 3 hours at an average speed of 45 kilometers per hour. We are going to use this information to find her average speed for the whole journey. Let's consider this simple illustration. So let's say that here is the cyclist. She started at point A. We know that for 2 hours, she traveled at an average speed of 35 kilometers per hour. So let's say that after 2 hours, she got to the point B. We know that she was traveling at an average speed of 35 kilometers per hour, and she traveled for 2 hours. This was the first part of her journey. Then she continued from point B to point C. From point B to point C, she traveled for 3 hours at an average speed of 45 kilometers per hour. So for the second part of the journey, she was moving at an average speed of 45 kilometers per hour, and she traveled for 3 hours. We are going to use this information to find her average speed for the whole journey. In order to find her average speed for the whole journey, we will need the total distance covered by the cyclist. So we will need the distance between point A and point B. After that, we will need the distance between point B and point C. When we find the distance between point A and point B and point B and point C, we can add them to get the total distance for the whole journey. When it comes to the time taken to cover this distance, we already have it. We know that for the first part of the journey, the cyclist spent 2 hours. For the second part of the journey, the cyclist spent 3 hours. So the total time taken to cover this distance will be 2 hours plus 3 hours, which is 5 hours. What we don't know is the total distance covered by the cyclist throughout the journey. So first, we will need to find the distance for the first part of the journey, and then the distance for the second part of the journey. Now, let's begin. We are going to find the distance for the first part of the journey. We know that for the first part of the journey, the average speed was 35 kilometers per hour, and the time taken to cover the distance was 2 hours. We know that average speed is equal to distance covered divided by time taken. We are looking for the distance, so let's represent that with a variable. Let's say x. We know average speed to be total distance covered divided by the time taken. The average speed is 35 kilometers per hour. The distance, we have represented it with x, and the time is 2 hours. So we can find x in this equation. We have x divided by 2 hours is equal to 35 kilometers per hour. It's the same as 35 kilometers per hour is equal to x divided by 2 hours. Let's find x. We will multiply the left hand side by 2 hours. We multiply the right hand side by 2 hours. So 2 hours and 2 hours will cancel each other out. So x will be equal to 35 kilometers per hour times 2 hours. 35 times 2 will give us 70. Kilometers per hour times hour will give us kilometers, because hour and hour will cancel each other out. So x is equal to 70 kilometers. So it means that for the first part of the journey, the cyclist covered 70 kilometers in 2 hours. So we now have the distance for the first part of the journey. We need the distance for the second part of the journey. So let's find that. The second part of the journey, the average speed changed to 45 kilometers per hour, and the cyclist spent 3 hours. So let's find the distance. Let's represent that with a variable. Let's say y. Now, we know that average speed is equal to total distance covered divided by time taken. Average speed is 45 kilometers per hour. Total distance is now y, and time is 3 hours. So let's solve this linear equation for y. We multiply the left hand side by 3 hours. We multiply the right hand side by 3 hours. So 3 hours and 3 hours will cancel each other out. 3 hours times 45 kilometers per hour will give us 135 kilometers, because 3 times 45 will give us 135. Hours times kilometer per hour will give us kilometers, because hour and hour will cancel each other out. So y is equal to 135 kilometers. This means that for the second part of the journey, the cyclist covered a distance of 135 kilometers in 3 hours. Now, we have the distance for both the first part of the journey and the second part of the journey. We have the time for both the first part of the journey and the second part of the journey. So we can now find the average speed for the whole journey. The average speed for the whole journey will be the total distance covered by the cyclist divided by the total time taken to cover that distance. The total distance covered by the cyclist will be the distance for the first part of the journey, which is 70 kilometers, plus distance for the second part of the journey, which is 135 kilometers. And we will divide it by the time for the first part of the journey, which is 2 hours, plus time for second part of the journey, which is 3 hours. 70 kilometers plus 135 kilometers will give us 205 kilometers. 2 hours plus 3 hours will give us 5 hours. 205 divided by 5 will give us 41. Kilometer divided by hour will give us kilometer per hour. So 205 kilometers divided by 5 hours will give us 41 kilometers per hour. This means that for the whole journey, the cyclist was traveling at an average speed of 41 kilometers per hour. Thank you for watching this video. Subscribe to this channel for more videos. This is the end of the videos on rates.